So, hello students, how are you? Hope your preparations are going well for your coming JEE exams. So, we have come a far way in moving through all the chapters, and today we will start a very important chapter, which is equilibrium. Now, in today's class, our focus will be on physical and chemical equilibrium. So, basically, there are two parts of it. The first one is physical and chemical equilibrium that we are going to cover today, and the second one is ionic equilibrium. So, this will be our day 12 of JEE 40 days crash course, and we will be covering the chapter physical and chemical equilibrium. So, join the class quickly so we can begin our discussion. This is our disclaimer. Okay, so first I will see that what is the weightage of this chapter. So, the approximate weightage is 4.1%. In every paper you will see at least one question from this chapter, or if you will not see a direct question, then you will see a question which will use the equilibrium concept. So I think most of you are facing difficulty in this chapter, and I've seen students facing difficulty in this equilibrium, but believe me, it's very easy. But only thing that you need to know is the concentration. So concentration terms are used in this chapters to and fro. If you are confident about that thing, then I am sure that you will be able to understand this chapter in a very easy manner. So we will try to solve numericals as much as possible so that we can get a clear glimpse of this chapter. Now, if I talk about the important topics from this chapter, then from equilibrium, first of all, the most important thing is the buffer solution. Okay, so you will every time see a question from buffer solution and from salt hydrolysis. So this is the part coming from your ionic equilibrium. Now, what about the physical and chemical equilibrium? So the most common thing that is being asked in this part is your Kp-Kc relation and Kc calculation using the table. Okay, so you know how to calculate the concentration from a given condition. So that is the most important part, where you will be given a condition and then you will be asked to calculate the Kc, or you will be asked to calculate the equilibrium concentration of various components present in that solution. If I look upon the years, so if at 2024 there was a question from acid, base and salt. Okay, then we can see a question in 2023 from relationship between K, Q and G and solubility equilibria of sparingly soluble salt. Similarly, in 2022, you can again see a question of law of mass action, which is coming from your K calculation. Got it? So I would say that your ionic equilibrium part is something which is more important as compared to the physical and chemical equilibrium. So that is the reason we are covering it for one day, and for tomorrow's and the day after tomorrow class, we will be seeing the ionic equilibrium only. Now, if I talk about 2019 and 2020, then again here you can see that questions are asked from the ionic part. So one is from the ionic part in 2019, most of the questions, and in 2020 there are some questions from ionic as well as from the physical part. Okay, so we shall now begin our class. Now, starting from the first thing, which is equilibrium involved in the physical processes. So please join the class quickly. So this is very important to understand, because it forms all of the basis of this equilibrium and your ionic equilibrium as well. So you know it very well that equilibrium is present in two kind of processes or two kinds of system, one which involves the physical processes and the other which involves the chemical processes. Now I need not have to mention what is physical and chemical processes. You are well aware about it. So we can try to understand the equilibrium in such processes with the help of some examples. For example, if we take the case of solid liquid equilibrium. Okay, first is solid liquid equilibrium. So it's very easy to take an example of ice and water to understand this. Now, when you see that the rate of melting of ice is equals to the rate of freezing of water, then in that case you will say that your equilibrium is been attended. Now, what we can say, what are the characteristics of equilibrium? The first characteristic that you need to notice is that the value of each and every measurable quantity becomes constant. Suppose if the rate of melting of ice and the rate of freezing of water is same, then the amount of water and the amount of ice will remain same. So in that way, the mass will remain same. Okay. Next, what you can observe is that it is a kind of dynamic equilibrium because the system is not stopping to undergo processes. Rather than that, both processes are going on simultaneously, but at the same rate or at the same speed, I would say. Talking about liquid gas equilibrium, we can take the example of water and water vapor, which are at equilibrium at your boiling point. Remember that all of these phenomena of physical equilibrium are seen at their constant boiling or melting point, depending upon the situation that we are encountering. Suppose you are taking solid liquid equilibrium, so you will see solid liquid equilibrium at 0 degrees Celsius only if the pressure is maintained at 1 atm, means the atmospheric pressure. So in that case, your equilibrium will be attendant on 0 degrees Celsius. Similarly, if I talk about water at 1 atm, then the liquid gas equilibrium is seen in the case of 100 degrees Celsius temperature. Moving on to the last one, which is solid gas equilibrium, that involves the conversion of your solid into vapor phase directly. We can take the example of naphthalene in the solid form going into the vapor phase. I hope this part is clear to you. Now 2 points are noteworthy. What are those 2 points? First of all, equilibrium is maintained only in dynamic situation. Okay, in dynamic case. Okay, first thing that. Second thing is that your equilibrium should be maintained in a closed system. I will try to explain this. Suppose you are taking an open container, right? And you put water inside it. What will happen? Water will evaporate. There will be never a situation you will see an equilibrium. So it should be a closed system. Then and then only your equilibrium can be observed. So first, every equilibrium that you will encounter will be dynamic, and second, it will be observed in a closed system where the system is closed. I mean that the exchange of matter is not possible, only the exchange of energy is possible. Got it? Second point. What is the third point? That for physical equilibrium, it should be done at a certain temperature. Like in the case of water, if you see, the solid liquid equilibrium is observed at 0 degrees Celsius. Similarly, the liquid gas equilibrium for water is observed at 100 degrees Celsius, given that your pressure is kept at 1 atm. Got it? Okay. So any doubt till this point? Anyone who has a doubt till this point? You can just post it here in the comment section. Is it clear to all of you? So please send a thumbs up to assure that you are getting all my points. Those 3 points I mentioned right now. Okay. Now, moving on forward. So, next we have dissolution of gas. So this dissolution of gas is something which is related to Henry's law. So in this case also, the equilibrium can be maintained. How? So basically, when you keep the pressure constant, so we have learnt about this Henry's law, that the dissolution of gas into the liquid depends upon the pressure with which it is exerted into the liquid solution. So if you maintain the pressure and the temperature, then after a certain time, you will see that the mass that is present inside the liquid solution of the gas becomes constant. So that is the example of gas liquid equilibrium. Got it? In the case of solution. Next, we will just sum it up. So we will see the basic points what we have seen in a short while. First of all, in the case of equilibrium, the value of all the measurable properties of the system remains constant. Take volume, take pressure, take temperature. So all of these things becomes constant at the equilibrium. So first point, remember these theoretical points that you are seeing are very important to solve equilibrium numericals, because this will give you a view of what is going on into the numerical. Okay. So imagining the situation is very important to do the numericals rather than to put the values and solve it. Second thing, as I said, it should be attendant only in a closed system. Got it? So this is important. The system should be closed. Matter should not be exchanged. Only the energy need to be exchanged. Third point, equilibrium is dynamic in nature always. It is not a case of static equilibrium. The transformations are continuous but are simultaneous and have the same rate in both the directions. Next, as I said earlier, the physical equilibrium is characterized by a constant value of any of the parameter. As I said, you should have a fixed temperature. Okay, if you change the temperature, the equilibrium will of course change. Got it? And lastly, the magnitude of this parameter at any stage shows the extent of physical process up to which it has proceeded. So I would say that these four points, above 4 points, are very, very important. Got it? The above 3 points are for every equilibrium, both physical and chemical. The fourth point is mandatory for the physical equilibrium. Got it? Okay. So as I said, that it should be seen only at certain parameter. For boiling of water, it should be 100 degrees Celsius at 1 atm pressure. For melting of ice, it should be 0 degrees Celsius at your 1 atm pressure. Why I am saying that pressure should be maintained? You know it very well. So just think about it. I am leaving this thing upon to you. Why pressure should be constant. Now moving on to the next thing. Sorry for the interruption. So moving on to the next thing, which is chemical equilibrium. So anyone who has a doubt till this point can just comment their doubt in the comment section. So next is the most important part, I would say, from where the numericals are asked often. So when we say that in the case of reversible reactions, okay, when the rate of forward and backward reactions become equal, then in that case we will say that your system has attained a chemical equilibrium. And at that point, the concentration of reactant and products are not changing. Got it? Did you get my point? What did I say? I said that the rate of reversible reaction at which the concentration of the reactants and products are not changing is known as the chemical equilibrium. Now, here is an important part. I would say it is not that much important from a JEE part of view, but you will see these things in your books that are, I would say, in a standard books like a Pradeep and all. You will see this kind of thing. So I am trying to explain it so that you don't face difficulty in understanding those. So here it is written active mass is equals to molar concentration. So when you will go in higher classes, you will see that your equilibrium constant is defined for active mass, not for concentrations. But at a low concentration, this active mass equals to the molar concentration. So rather than taking active mass, we take this molar concentration. So this is just a small note for you. You don't need to stress much upon it. Okay. Next, if H2 and I2 are reacting, then it will form 2HI, and this PCl5 is dissociating back to PCl3 and Cl2. So these are some examples of reversible reaction in which you can observe the chemical equilibrium. Okay. Next, classification of chemical equilibrium. So what are the types of chemical equilibrium that we can see? So it depends upon the physical state. First one is known as homogeneous equilibrium. So it's very simple to understand. If all your reactants and products are in the same state or in the same phase, then in that case you call that your equilibrium is homogeneous in nature. Can we take an example? Yes, the formation of ammonia. So in ammonia formation, all the species, whether the reactants or the products, you take nitrogen, hydrogen, ammonia, so all of them are in the same state, that is the gaseous state. Next, we can take the hydrolysis process where your acetic acid is reacting with ethanol to form the ester. Okay, in that case also all the species are present in the liquid state. See, it is written here. So this is in the liquid state, this is again in the liquid state, and this one and this one. So that is the reason these two are the examples of homogeneous equilibria. Next, heterogeneous equilibria. So when more than one phase is present in the reactant or in the product, then we call it as the heterogeneous equilibria. For example, the calcium carbonate, which dissociates into calcium oxide and carbon dioxide. So calcium carbonate is present in the solid form and also your calcium oxide, but the carbon dioxide is present in gaseous form. So here you are observing two phases in the same equilibrium. So it is an example of heterogeneous equilibria. Similarly, you can take the example of NH4SH, which is dissociating into NH3 and H2S. Here also you can see that the products are in the gaseous phase, whereas the reactant it is the solid phase. So two phases are available. Therefore, it is an example of heterogeneous equilibria. I hope this is clear to you. Next, equilibrium constant. So far, we have moved upon all of this: physical, chemical equilibrium, characteristics of equilibrium, and your homogeneous and heterogeneous equilibrium. Now we will see what is equilibrium constant. So it is directly coming from the law of mass action, which says that at a given temperature, the product of the concentration of reactants, okay, and the product which are raised to their respective stoichiometric coefficient. So you know what is stoichiometric coefficient. So in a balanced chemical equation, whatever is written before the symbol of the compound or the element is known as the stoichiometric coefficient. So when you take the product's concentration in the numerator and raise them to the power which is equals to the stoichiometric coefficient, then you divide it by the denominator by the reactant's concentration with each species raised to their stoichiometric coefficient, then you get your equilibrium constant, which is Kc. Okay, and this is known as law of chemical equilibrium. Suppose we take a generic reaction A plus B giving us C plus D, where small a, small b, small c and small d are indicating their stoichiometric coefficient in the balanced chemical equation. So this is a example that we are taking. Now we know that the rate of forward reaction, means going from reactant side to the product side, is directly proportional to the reactant's concentration. So more is the amount of reactant, more the reaction will go in the forward reaction. Got it? So that is the reason your rate of forward reaction is directly proportional to the reactant's concentration. Similarly, you can write it in the mathematical form by removing the proportionality constant and introducing Kf. Okay, so this Kf is the proportionality constant. Similarly, the rate of backward reaction can be written as directly proportional to the concentration of C, concentration of D, with each raised to the power equals to the stoichiometric coefficient. Again, you can remove the the proportionality constant and write it as rate of backward reaction is equals to Kb multiplied by concentration of capital C raised to the power small c, concentration of capital D raised to the power small d. So is this clear to you why I am writing it as directly proportional? Because if you want to form more and more product, you should have more and more reactant. Similarly, if you want to form more and more reactant, you should have more and more product. So this is for reversible reaction and it is propagatable in both directions. Remember, we have to increase the power to the stoichiometric coefficient. See, a, small b, small c, small d are the respective stoichiometric coefficient, and we are putting the same power above the species. Is it clear to all of you? Any doubt till this part? Anyone who has a doubt till this part? You can just comment it here if you have a doubt regarding this. So we are slowly moving to this equilibrium constant, and then we will talk about equilibrium constant in various conditions. So this is very important to understand to solve numericals, right? Okay, I hope this is clear to all of you. Now we will move on to the final derivation of this equilibrium constant. As I said that at equilibrium, the rate of forward and backward should be same. So from that perspective, your RF and RB can be equalized and then their respective value can be put here, which is Kf A raised to the power A, B raised to the power B is equals to KBC raised to the power C and D raised to the power D. This is clear to you? Now, just rearranging the equation, you will get Kf by Kb and you write this Kf by Kb as capital K. Got it? So, this is your final equation to calculate the equilibrium constant K, which is concentration of product raised to their stoichiometric coefficient divided by the product's reactant's concentration raised to their stoichiometric coefficient. Now, here Kf is the rate constant for forward reaction, Kb is the rate constant for backward reaction, and the above expression is known as law of chemical equilibrium. Now, for a gaseous reaction, what we can do? We can define a similar equilibrium constant. So, you can use this one also where concentration is used. So, in that case, you will write it as Kc specifically for concentration. And if you want to write it for gaseous species, you can write it in terms of concentration also or in terms of pressure also. So, for pressure, we have written it here. So, partial pressure of C multiplied by partial pressure of D divided by partial pressure of A multiplied by partial pressure of B. Again, we are raising each of the term to their stoichiometric coefficient, respective stoichiometric coefficient. So, that should be same. Got it? Now, as I said here, that the equilibrium constant is it in terms of partial pressure. So, this one is in terms of concentration of each species and this one is in terms of partial pressure of each species. So, partial pressure is basically the individual pressures in the complete solution. So, if you take a reaction mixture, you have A present there, you have B present there, C and D. Each of them are gaseous in nature and they will have their own individual pressures and that thing only named as partial pressure, as simple as that. Now, moving on further. So, you can write equilibrium constant in basically three ways. These are very, very important. First is Kc, where you use the concentration terms. Then, second is Kp, where you use the partial pressure of the different things. Third one is the mole fraction. So, you can also write the respective mole fraction. Suppose there are 4 components similar to that of the previous one. So, we can take their respective mole fraction. Here, we have taken the mole fraction of C, mole fraction of D divided by the mole fraction of A multiplied by the mole fraction of B. Again, the power should be always equals to their stoichiometric coefficient, no matter in which way you are representing your equilibrium constant. So, this is a very important point to remember. What did I say? I said that no matter how you are representing the equilibrium constant, rather in terms of concentration or in terms of partial pressure or in terms of your mole fraction. But remember one thing always, that you should have the stoichiometric coefficient as the power in each case. So that is something which should be constant in each and every representation. So is it clear to all of you? So now we will see a relation between each of them, between Kc, Kp, between Kp, K chi. So this chi is basically the mole fraction. So is this part clear to all of you? Any problem in this? So can you please send a thumbs up if you are attending it? Apart from Dhruv and Partham, I am knowing that you are attending. But apart from you, anyone else who is attending this lecture, you can please send a thumbs up so that I can get an idea if you are getting my lecture or not. So we have moved half of this physical and chemical equilibrium. So this would be given in your question. Okay, so you will be given with your reaction. In case the reaction is not balanced, you will balance it. Okay. Okay. So anyone else who is the doubt in this? Is it clear to all of you? So if you face a difficulty, please ask questions. Okay. So that is the reason I am sitting here. Now, next, we will move on to significance of equilibrium constant are as follows. So, first of all, what does this Kc define? So, if your Kc have a value greater than 10 to the power 3, that means simply if your Kc is greater than 1000, then it indicates that your reaction is predominated is dominated by the product concentration, means more and more product is formed. Okay, it's very simple to understand. Second thing, if Kc is less than 10 to the power minus 3, means it is less than 0.001, then in that case your reactant is predominate. Okay, and in the third case, if it is between 10 to the power minus 3 and 10 to the power plus 3, then in that case the concentration of reactant and products are intermediate, means no one is dominating. I hope this is very simple to understand. Now, with the help of the equilibrium constant, we can also predict the direction of reaction. And for that case, we have a different term. So, when you are calculating the equilibrium constant, or when you are applying this law of mass action to any reaction at equilibrium, then in that case, the value that you get is your equilibrium constant. But in place of that, if you are applying your law of mass action at any certain point, means any random point, when the equilibrium is not attended, then in that case, you will tell that your given value is the reaction quotient. So these are such two important points. Got it? Again, I am repeating my part. If you are calculating your K, or I would say if you are applying the law of mass action, means you are putting the product concentration in the numerator, reactants concentration in the denominator, which each raised to the power to their stoichiometric coefficient, you are getting some value. And if you are putting the concentrations of equilibrium, then you will get the equilibrium constant. But if you put your values at any random situation where the equilibrium is not attended, then in that case you will call that value as reaction quotient. Got it? Suppose I say that the concentration of each of the term of a particular reaction should be 5 molar, then and then only the equilibrium is attained. Got it? But in place of that, if you find that your concentration is not 5, it is 4, and in that case, if you calculate the, or if you apply the law of mass action, then the value that you will get is your reaction quotient. Now this Kc and Q, which is the reaction quotient, helps in predicting your direction of your reaction. Okay, so for a general reaction which is represented as A plus B going to C plus D, if you define the reaction quotient, then you can define it in two ways. Remember, I am saying that this given reaction, suppose it is not in equilibrium, the stage has already not reached, it is going to reach. Got it? Or it has reached but it has dominated that part. Two situations are there. Either the equilibrium is left behind or equilibrium is about to come. In both that case, if you calculate the products by reactants concentration, you will get the reaction quotient, which is Qc. Similarly, if you try to calculate it in terms of pressure, then you can also have a reaction quotient Qp. At any stage of the reaction, how we can predict the direction? Suppose you calculated the Qc and you see that your Qc is greater than Kc. Now, how your Qc can be greater than Kc? It means the product's concentration is more. So that is the only way. If your product's concentration is more, then where should the reaction go? The reaction should go in the reverse direction. Are you getting my point? So if I say that your Qc is greater, then that means your numerator is greater. And if your numerator is greater, that means your product's concentration is more. In that case, what will the reaction do? The reaction will want to go in the equilibrium stage and it will go in the reverse direction to do so. Got it? Similarly, second case can be that your Kc is greater, means your Qc has a less value, means the denominator value is high. Okay, to keep this fraction less, what you can do? You can keep this denominator value high. That means your reactant's concentration is more. In that case, the reaction will proceed in the direction of product so that the equilibrium can be attained. What is the third case? Obviously, there is a chance that you calculate this value, this ratio, and you get equals to the Kc. Then in that case, you will say that your reaction mixture is already at equilibrium. Is it clear to all of you? Any doubt in this part? So this is very crucial to understand and yet very simple at the same time. Still, if you are facing difficulty, please ask me. Okay, so I am explaining them once again. Suppose you calculated the ratio of the product to the reactant. Got it? And you saw that your Qc value, okay, or this ratio has a greater value than that of Kc. Means this value is greater than that of Kc. Now, how can you decrease this value to make it equal to Kc? What you can do is simply reduce this numerator value and decrease this denominator value. And it is simply, in a way, conversion of your product to reactant, that means your reverse reaction. So, what we can conclude, that if your QC is greater than Kc, then to make this ratio equals to Kc to attain the equilibrium, what will the system do? The system will increase the numerator and decrease the numerator and increase the denominator, and that is conversion of product into reactant, that is the reverse reaction. Similarly, if your QC is less than Kc, got it? If your QC is less than Kc, that means this fraction is having a lesser value than Kc. Okay. Now, how can we increase this fraction value? It's very simple. You increase this product concentration and decrease this reactants concentration, and that can be done in moving the reaction in forward direction. Okay. Now, is it clear to you? Still, if you have a doubt, you can ask in the right now, or anyone else who has a doubt in this part. The third case is very obvious. If both values are equal, that means equilibrium is already attained. Okay. Now, next, moving on to very important relations which is between your Kp, Kc and Chi. First one, Kp is equals to Kc RT delta Ng. Here what is delta Ng? So delta Ng is basically the change in gaseous moles. So if I say you that we are going from calcium carbonate to calcium oxide plus the CO2. What did I say? We are going from calcium carbonate to calcium oxide and CO2. Remember, the calcium carbonate and calcium oxide are in the solid state and your CO2 is in the gaseous phase. Then in that case, what will be the change in gaseous moles? Anyone, can you tell me? Again, I am repeating my part. You are going from calcium carbonate to calcium oxide and carbon dioxide. Then what is the change in gaseous number of moles? Just try to write the equation. Remember that calcium carbonate and calcium oxide is in the solid phase. So you will not take their pressure. That is the reason the delta Ng will not include them. Yes. Any more? Anyone else who can give the answer of this? So I am getting one answer as 1. It's very simple to understand what I am trying to depict here. So you are going from calcium carbonate to calcium oxide and carbon dioxide, and you have to calculate the change in gaseous moles. Remember, calcium carbonate and calcium oxide are in the solid phase and carbon dioxide is in the gaseous phase. Okay. So I am getting more answers as 1. Okay. So very good. So the correct answer will be delta Ng will be equals to 1 for the decomposition of calcium carbonate. Similarly, you can try to calculate it for the dissociation of PCl5. So PCl5 dissociates into PCl3 and your Cl2. But in this case, all the species are in the gaseous phase. Now, I am leaving this question on to you. Next one, the second relation is between Kp and Kchi. So Kchi is basically the equilibrium constant in terms of mole fraction. So Kp is equals to Kchi P delta Ng, where P is the pressure. Okay. So it is the total pressure. I mean the total pressure, right? So remember, this is very important to remember. The terminologies are very, very important. T is the temperature, P is the total pressure or the pressure of the equilibrium mixture that you are considering. Next, R is what? The gas constant. T is the temperature in Kelvin. Then we have delta Ng, which is gaseous moles of products minus the gaseous moles of reactants. Next, if delta Ng is equals to 0, then what will happen? If this things is equals to 0, that means RT is raised to the power 0 and something raised to the power is equals to 1. So in that case, Kp and Kc will be equal. If delta Ng is positive, So if this thing is positive, got it? That means Kp will be greater than Kc. Similarly, if your delta Ng is negative, that means Kc is less than what? Sorry, Kc is greater than Kp. I hope it is very simple to understand. So these are some outcomes of this equation. Got it? Moving on to the next part. So any doubt in this? Okay. Next is factors affecting equilibrium constant. So this is very, very important. So first important thing I would say is your equilibrium constant. Second important thing is your factors affecting equilibrium, and third one is your Le-Chatelier principle. So these are the three main parts of your equilibrium, physical and chemical equilibrium. Now your equilibrium constant, which is your Kp and Kc, is not dependent upon pressure, volume, pressure, volume, concentration and catalyst. So write it in bold letters in your mind. Okay, keep this thing in your mind always, that your Kp or Kc or any other equilibrium constant that you take in terms of pressure, or you're taking Kp, Kc or Kchi, anything that you are taking, it is only dependent upon temperature and not upon the pressure or upon the value or volume or upon the concentration or catalyst. The value of K is fixed and it can only be changed when you change the temperature. So this is the very important point and you should always keep it in your mind. Next, the equilibrium constant is independent of the reaction mechanism. It is only dependent upon the product and reactant. As simple as that. How it is going, it is acid catalyzed, is it base catalyzed, no matter how is the reaction going, your equilibrium constant will have a same value. It will only change when the temperature is changed. Got it? Third point, equilibrium constant is dependent upon stoichiometric coefficient. Got it? How? For example, if I take an equation where H2 and I2 is going to form Hi, 2 moles of Hi, and I tell that the equilibrium constant in terms of concentration is Kc1, then what we can do is, suppose if I change the equilibrium by introducing stoichiometric coefficient, a different stoichiometric coefficient. So here we are writing it as half, and here we are writing it as 1. So we have divided the whole equation by 2. Now what will happen? How will the equation change? How will your equilibrium constant change? So the new equilibrium constant, which is Kc2, will be the root under of previous one. So how it has came? What is the relation? It's very simple. The stoichiometric coefficient with which you are dividing or multiplying your all over equation, you will keep the power of that previous one to get your new one. Okay. Suppose this equation was having 1 as your coefficient for H2 and I2 and 2 as a coefficient for Hi, and its equilibrium constant in terms of concentration was Kc1. Then in the next part, you are dividing this whole equation, or you can say you are multiplying this whole equation by half. Okay. Then in that case, how will your equilibrium constant change? So your equilibrium constant will have a power of half. Okay. So now your new equilibrium constant will be root under Kc1 or Kc1 raised to the power half. So in this way, you can calculate the new equilibrium constant if you are changing the equation. Next, now suppose I am reversing this equation. Okay, I am making your product as your reactant and your reactant as your product. Then what will happen? Your equilibrium constant will be reversed. Initially it was Kc2 and now it is 1 by Kc2. Then if I try to relate it in terms of Kc3 and Kc1, then you can put in place of Kc2 root under Kc1. You got my point. If you are multiplying by a stoichiometric coefficient, then it is going to the power. And if you are reversing the equation, then the equilibrium constant is becoming the reciprocal of the previous value. Is it clear to all of you? Any doubt in this part? It's a very important point, because sometimes you get equilibrium constant for a particular reaction, then you change the stoichiometric coefficient and the whole story changes. So these are the two ways your stories can change if you are doing operations on a single reaction. First thing, you are changing the stoichiometric coefficient, so that goes to the power. Suppose I say that for this given equation, the equilibrium constant is 25. Then for this equilibrium situation, your equilibrium constant will be 25 raised to the power 1 by 2 or root 25, which is 5. Then if I ask that what is the equilibrium constant for the third situation, then it will be 1 by 5, which is 0.2. So can I give you a question? Suppose I say that your equilibrium constant for the first equation is 16. Then can you tell me that what will be the value of Kc2 and Kc3? Again, I am repeating my question. Your equilibrium constant for the first situation is 16. Then what will be the equilibrium constant for your second and third situation? Anyone? It's very simple. Right in front of your eyes. So I'm just giving this direction so that you can get a picture of what you are doing. Okay? You can be engaged in the lecture. So the Kc1 has a value of 16. So what will be the value of Kc2 and Kc3? Yes, very good. So it will be 4 and 0.25. Anyone else? Yeah. Okay. Yes, the correct answer will be 4 for Kc2. And if you take the reciprocal of 4, it will be 0.25. I hope this is clear to all of you. You can try more and more operations. So this is regarding a single equation. Now, moving on to the next situation. Suppose if the reaction is multiplied by n, then as I said, the new equilibrium constant will be having a power of Kc raised to the power n. Second situation is that if you are adding two equations, got it? Listen to it very carefully. You are adding two equations. Suppose the first one is P going to Q and Q going to P, which is having an equilibrium constant of K1. Second one, R going to S and S going to R has an equilibrium constant of K2. Then if you add both of these equations, what will you get? You will get P plus R giving us Q plus S. And in that case, your new equilibrium constant will be K1 into K2. Now this is the situation where you are doing operations on two chemical equations. Previously it was for one only. Here it is for two chemical equations. So what did I say? If you add two equations, then their equilibrium constant is multiplied with each other. Very simple. So if 4 is the equilibrium constant for the first case and 5 is for the second case, then for the addition of both of them, you will get your equilibrium constant as 5 into 4, which is 20. Then for exothermic reaction, if you increase the temperature, the Kc will decrease. So we'll talk about it in detail. And for endothermic, the Kc will increase with increase in temperature. So leave this for 6 point for the next upcoming slide. So did you get all my point from the previous one? First thing, what did I say? If you are multiplying the whole equation by a stoichiometric coefficient, then in that case, it will be raised to that same power. Okay. In the second case, if you are reversing the equation, then your equilibrium constant will have a reciprocal value. Okay. 1 by, it will become 1 by. Third situation, if you are adding two equations, your equilibrium constant will be multiplied with each other. Now let me put a question for you. If you are subtracting two equations, then what will happen to the equilibrium constant? What will be the operation that will be operated on it? Suppose I said that you subtract these two equations. So PQ minus RS. Then whatever reaction you will get, what will be the impact on their equilibrium constant? How will they perform? Anyone? Think about it. Again, I am repeating my question. Suppose rather than adding two equations, I am subtracting two chemical equations. Then what will be the operation on their respective equilibrium constant? So if in the case of addition, you are multiplying K1 and K2, what will happen in the case of subtraction? Any idea? Just apply the simple logic. What will be the new equilibrium constant? Whether it will be K1 into K2. Yeah, so that will be division. Yeah, so you can just try it out. Just try it out by yourself. Suppose if I say that, what is K1? So K1 would be Q, concentration of Q divided by concentration of P. Okay. Now what is K2? concentration of S divided by concentration of R. Then if you try to find out the equilibrium constant for this equation, it will be Q into S by P into R. So it is coming from that logic. It is not that we are simply doing it in air or in blind sense. So you can simply apply and try this out. What did I say? If I write K1 for the first reaction, it will be Q by P. K2 will be R S by R. And for this one, suppose I write it as K3, then it will be QS by PR. Now that is what? That is simply multiplication of K1 and K2 and nothing new. Okay. Similarly, if you subtract two equation, what you will get? You will get it as P plus S giving us Q plus R. Since you are subtracting, your equation, this equation will be reversed in a manner. So you will get it as P plus S Q plus R. And for that case, you have to write your new equilibrium constant as K1 by K2. Okay, just try this out. It's very simple and fun to do activity. Now, moving on to the relationship between delta G and delta K. Okay, so we have learnt about this equation in the thermodynamics also. So I am putting this again here because it is relatable. So delta G is equals to delta G naught plus 2.303 RT log Q, where Q is the reaction quotient, delta G is the Gibbs free energy, and delta G naught is the standard Gibbs free energy. So as I have told it earlier also, so please try to attempt the DPPs from our website. It will help you to do your lecture part with a proper situation, right? So if you are bugging up the theory, so that will not help you until and unless you solve questions, and our DPPs are very good enough and very much oriented for the JEE examination. As well as you can try the mock test also, and we will be having our all India mock test. So I will request all of you to please register there so that you can get an idea of your preparations going right now. Now, under equilibrium condition for same number of moles of reactant, so your Q will be equals to Kp is equals to Kc is equals to K. So you know it very well. So at equilibrium, your Q becomes to Kp, and in that case, your delta G is equals to 0 at equilibrium. Therefore, you will get your equation as delta G naught is equals to minus 2.303 RT log K. So this is the equation modified at equilibrium. Now, next. So next we have significance of delta G naught. Why we are calculating delta G naught? So just write it down. These are some very important points. So if your delta G naught is less than 0, we know it very well that if it is negative, that means your reaction is spontaneous in nature, and it means it can go well in your product direction. And if it is going in the product direction in a good manner or in an appropriate amount, so that means product will be formed and K will be equals to, or sorry, K will be greater than 0. Got it? So that is directly coming from that point. Log K will be greater than 0 and K will be greater than 1. Therefore, forward reaction is spontaneous. Similarly, if your delta G naught is greater than 0, that means if it is positive, so from the previous equation, log K is less than 0. So it is directly coming from the equation delta G is equals to minus RT log 2.303 log K. Okay, we are deriving this from that equation. So if delta G is greater than 0, that means log K is less than 0 and K is less than 1. That means reaction will go in the backward direction or spontaneous in the backward direction. So it's very obvious, and now we are telling it in the terms of equilibrium, and we have seen it in terms of the thermodynamics. Lastly, if it is equals to 0, that means log K is equals to 0 or K is equals to 1. So that means reaction is at equilibrium already. Then moving on to the relationship between degree of dissociation and density. So this will help you to solve numericals. How you will solve it? So if alpha is the degree of dissociation of gaseous compound, then its vapor density can be written as alpha is equals to D minus D by D into Y minus 1. Where D is what? It is the molar density before dissociation or initial density. D is the density after dissociation. Then Y is the number of moles of product, and density or the vapor density is molecular weight by 2. You will understand this equation when we will do problems on it. Okay, so if you are not getting this, no issues. We will try to understand the same with the help of the problem. Next, we have factors affecting equilibrium. So let me go through them quickly. So if you are trying to change the concentration, then or any other parameter, then the reaction will respond in such a way so that the effect of that change can be minimized. So always a system wants to be in equilibrium. If you disturb that, then the system will react in such a way so that your disturbance can be minimized. So your disturbance can be minimized, so the reaction will try to displace or reduce that disturbance. Now, what are the different factors that affect your equilibrium? First is concentration change. So if you add the reactant's concentration, okay, if you add to reactant, what will happen? If the system is suppose already at equilibrium and you added reactant to it, so what will the system do? The system will again try to reach the equilibrium because you have caused a disturbance. Now, to do so, it has to reduce the extra disturbance, which is your reactant concentration addition. How it will do so? It will move the reaction in the forward direction so that your extra reactant can be consumed and your equilibrium can be brought back into the picture. Suppose we have A plus B going to C plus C, going to C, and if you add A or B, then the equilibrium will go in that direction so that that extra A and B can be consumed and reaction will move in the forward direction. Similarly, if you add C, so the reaction will go in the backward direction so that your extra product concentration can be consumed. I hope this is clear to you. Now next we have effect of pressure. So at high pressure, reaction goes in that direction which has lower number of moles. Now why it is so? So basically, if you are exerting pressure, then what will happen? As a result of that, the number of moles will increase because pressure is directly proportional to number of moles. Got it? Now to reduce that effect or to reduce that number of moles, the reaction will go in that direction where there is lesser number of moles. For example, if you take the case of PCl5 going to PCl3 and Cl2, if you apply pressure on it, what will happen? The reaction will go in the backward direction because in the backward direction we have 1 mole of gas, which is PCl5. Whereas in the forward direction we have 2 moles of gas, which is PCl3 and Cl2. Okay? You can just write it down and understand this. If there is equal number of moles on both sides, then there will be no effect on equilibrium. Got it? Then if delta Ng is greater than 0, that means your product has a higher number of moles. In that case, your reaction will go in that direction which has lower number of moles, which is your reactant side. Third one, if it is less than 0, that means product has lesser number of moles. So if you apply pressure, the reaction will go in the forward direction. Moving on to the next part. Next we have effect of temperature. So what is the effect of temperature? So it depends whether your reaction is exothermic or endothermic. Suppose there is a reaction which is releasing heat, which means it is exothermic in nature. Now if you apply heat onto that, what will happen? The reaction will move in the backward direction. Why? Because if it is having an exothermic nature in the forward direction, it is very obvious that it will have a endothermic nature in the backward direction. So the extra heat you are applying, it can only be consumed if it goes to the backward direction. So this is true for your exothermic reaction. But if it is an endothermic reaction, what will happen? The reaction will move in forward direction so that your extra added heat can be consumed. Got it? So your equilibrium constant is directly proportional to T for endothermic process. Similarly, it is inversely proportional to T for your exothermic process. Next is your effect of catalyst. So in no other factor you will see that the K is changing, but only in this you are seeing that your equilibrium constant is proportional to temperature, because no other factor can affect this equilibrium constant apart from temperature. Then we have effect of catalyst. So catalyst can only increase the rate of backward and forward reaction. It will not change the reaction equilibrium concentration or the equilibrium constant. So it is very, very important to remember, and you will see this in the chemical kinetics as well. Last one, effect of inert gas. So if you are adding your inert gas at constant volume, then in that case there is no effect of that addition. But if you are adding at a constant pressure, then your reaction goes from lower number of moles to higher number of moles. Means to that side, where you have higher number of moles. Is it clear to all of you? So this last point is very, very important. If you are adding inert gas at constant volume, then there is no change or no change in the equilibrium or no disturbance in the equilibrium. If you are adding it at constant pressure, then the reaction goes from lower number of moles to higher number of moles. Got it? So are these points clear to you? Effect of concentration, effect of pressure, effect of temperature, catalyst and inert gas. Any doubt till this point? So we are moving on to last of our theory part. Then we will see the question part. So if you are waiting eagerly for that part, so please hold on. We are only 2 to 3 slides left behind. Okay. So equilibrium is like a chapter in which you have not a massive number of formulas. Your concept is important. Okay. You will see that I will use 2 to 3 formulas, not greater than that, to solve any problem that you will see right now. All is dependent upon concepts. Formulas count is less. So in ionic equilibrium, you have a greater extent of formulas, not in the case of physical and chemical equilibrium. Okay. Now, moving on to the last slide, which is an illustration. So your Le-Chatelier principle is applicable to both physical and chemical equilibrium. And if you see an application, you have an application to chemical equilibrium, which is your Haber's process. So this process, if I talk about this process, it is simply formation of ammonia from nitrogen and hydrogen, and this is an endothermic process. Now, what will be the effect of various changes? Suppose if you are applying high pressure, what will happen? Where will the reaction go? Anyone? So please tell me quickly, if I apply pressure, if I apply high pressure on this equation, where will the reaction go? Remember, high pressure is directly proportional to number of moles, so you have to counter this extra number of moles. So where will the reaction go? Whether it will go to in the backward direction or in the forward direction. Again, I am repeating my question. If you are applying high pressure, what will happen to the reaction mixture? Suppose your system is already in equilibrium and you are applying pressure. Then what will happen? Whether the reaction will go in the forward direction or in the backward direction? Anyone? So we are applying high pressure onto this equilibrium situation. Then what will happen to the reaction? Whether it will go in the forward direction or it will go in the backward direction. Remember, extra pressure means extra number of moles. So you have to counter this extra number of moles, or you have to consume this extra number of moles. Yes, the reaction will go in forward direction. So there is one answer. Let us see it if it is correct or not. Anyone else? Again, I am repeating my question. So you are applying pressure onto the equilibrium situation. Then what will be the result of this equilibrium? What will be the result of this pressure? Will it will go into the forward direction or it will go into the backward direction? So I would expect more answers from you, as it is a simple question, right? So those who have already known it, why it is going in the forward direction or in the backward direction, just give me a rationale for the same. What is the reason behind it? Why it is going in the forward direction? High time I ask question from you because we have covered the theory part. Anyone else who is willing to give the answer? In which direction the reaction will go? Yes, very good, Dhruv. Because of fewer number of moles, as we are applying pressure, pressure is directly proportional to moles. So it will go in the forward direction because it has fewer number of moles, which is 2. Of course, it is greater than 4, which is on the product side, on the reactant side. Anyone else who has a different answer from this? Partham, Varsha, anyone else? So what will happen if you apply pressure on it onto it? Okay. So as Dhruv said, so we have fewer number of moles on the product side, and if you apply pressure, the reaction will go in that direction which has fewer number of moles, because pressure is directly proportional to number of moles. Therefore, it will go on to the product side. Then it is exothermic in nature. So if you are keeping the temperature low, then it will go in the forward direction. Why? Because if it is exothermic in the forward direction, that means it will be endothermic in the backward direction. So if you are keeping, or if you are trying to lower the temperature, then the equilibrium will react in such a way so that that lower temperature can be countered. And how it can be countered? If it move in the forward direction and supply that same amount of heat, or release that same amount of heat, so that your lower temperature can be countered. Okay. Next, high concentration of reactant. So it's very obvious. If you increase the concentration of reactants, then the equilibrium will be disturbed. And to maintain the equilibrium, it will go in the forward direction, so that your extra concentration of your reactants can be consumed. And lastly, if you can remove the product, suppose if you keep on removing NH3, then what will happen? The product's concentration will go down. Now, to keep the system in equilibrium, back in equilibrium, it will go in the forward direction. So, what you do? You apply more and more pressure, you keep low temperature, you are keeping high concentration of reactant and low concentration of product. So, these 2 points are common in all of the reactions, because it is true that if you are increasing the concentration of reactants, then it will try to counter that by moving in the forward direction, and same is true for the removal of NH3. But these 2 points, which is high pressure and low temperature, it is specific to this reaction and will change from reaction to reaction. So this was all for the theory part. Now we will move on to the question part. Meanwhile, if you have a doubt in this theory part, you can post it here. And if you are not able to post it here, you can just come and ask it in the doubt clearing session of our SATHEE, which starts from 10 a.m. and move to 6. So here is the first question. I will just explain the questions and I will expect that you give the answers. Okay. Option A or B or C or D, right? The first question is saying us that you have the rate constant for the backward reaction, which is 7.5 into 10 to the power minus 4, and the equilibrium constant is given 1.5. You have to calculate the rate constant for the forward reaction. Okay, it's a very simple question. Just quickly try to solve it and give your answers in the comment section. So we have talked about this. We know the formula of calculating the equilibrium constant from this rate constant from of forward and backward reaction. We have seen this. So just quickly put the values there and give me the answer. It is a very simple question. Okay, if you are facing any difficulty in the theory part, then I hope it will be clear in your question part, because in physical, questions are important to get the idea rather than the theory part. So what will be the answer of this question? Punya Jain, Dhruv, VK, Partham. So I would expect answers from you and all who are attending it. Answer C. Okay, let's see if it is correct or not. So it's a easy one. Just try it by yourself. What will be the correct answer? I want answers quickly. Okay. So I'm seeing answers as C in most of the cases. Oh, let us move on to the solution. So the correct answer will be C. Very good. It will be 1.125 in 10 to the power minus 3. It's a very simple question. Equilibrium constant is equals to Kf by Kb. Now next, if you put the value of Kb and K here, for 1.5 is equals to Kf by 7.5 into 10 to the power minus 4. Just simply multiply it and you will get your correct answer. Any doubt in this? Anyone? You can just ask it here. It's a simple formula. We've seen this formula in the start also from the theory part. Okay. Now, next question. So, 56 gram of N2 and 6 gram of H2 were kept at 400 degrees Celsius in a 1 liter vessel. The equilibrium mixture contained 27.54 gram of NH3. Now, the approximate value of Kc for the above reaction in mole raised to the power minus 2 liter square is. So, what are you given? So, let me first explain the question for you. It is given that initially you have the N2's weight and H2's weight as 56 and 6. But when the equilibrium is reached, the NH3 concentration or the NH3 mass becomes 27.4. Got it? Now, from this data, you have to calculate the Kc. So, one very important point that we will see right now is the ICE table. Okay. If you know how to arrange it, it can be easily solved from that table. Or if not, I will tell you, don't worry. First, try to solve it by yourself. So, this is the type of question that is mostly asked. Okay. You will be given a situation where you will be given a mass and all, and you have to calculate the equilibrium constant. So, I will wait for some time. It is now 5:07. I will wait till 5:10. Okay. 3 minutes are hopefully enough for you. Just try it by yourself. At least analyze it, how you can do this problem. I will try to solve lesser questions but give the proper idea behind it. So please try to solve it by yourself. Then only you will see that where you are facing difficulty in solving the numericals. Okay. Please solve it quickly. You have 4 options. I said that you are given the concentration of H2, N2 at initial phase. Then you are given the equilibrium mixture concentration of ammonia. And you have to calculate the value of Kc. Remember, what equilibrium mixture should be discussed here? It is about the formation of ammonia. You will use that equation to solve it, which is N2 plus 3H2 giving us NH3. So, is anyone close to the answer, or you are completely blank about it? Should I start with the solution? Please don't use any tools to solve it. Solve it by yourself. You can only use calculator because time is something which is a constant in this case. Okay. So slowly I am moving on to the answer. Just see that whether you are following the same pattern that I will be following or not. Okay, so that would be enough for you. Or you need more time to solve it. Should I move to the answer? Anyone who is close to the answer? Okay, so I am seeing C here. So Varsha, Khare, Partham, VK, anyone else who is close to the answer? Or should I move to the answer right now? So I didn't give any formula for it because I plan to directly introduce you with the numerical. That would make more sense. Okay. But still, if since you are doing preparations, maybe there is a chance you have seen this kind of problems. So I'm giving you some time. Okay. So VK is saying D. Anyone else? Okay. So now I'm moving on to the answer. Just see that whether you followed the same path or not. If you are following, well enough. So 11.9 is your correct answer. Just focus here how I am solving it. First of all, this is your given equation, right? Now, if you see here, I have written, okay, Dhruv, no problem. So, we are given with the values of their masses. N2 has 56 gram, H2 has 6 gram, and your NH3 has 27.54 gram. Now, next, what we do is we simply calculate the number of moles. How do we do it? It's very simple. Just divide it by their respective molar masses. So, 6 divided by 2 for hydrogen, it is 3 mole. Then, for your N2 it will be 56 by 28, which is 2 mole. Moving on to the next. If you put these values here, so initially I said that we have 2 moles of N2 and 3 moles of H2, isn't it? This is the situation. So we have calculated the number of moles from here. For hydrogen it is calculated as 3 and for nitrogen it is 2. Now I said that this is the initial number of moles in the upper table. After some time, the reaction, when it will proceed further, we will get the product. So the reactant will be converted into product. I say that X amount of N2 is suppose dissociating to form the product. Then what will happen? Since for 1 mole of N2, 3 moles of H2 will react. Therefore, for X moles of N2, 3X moles of H2 will react. And for 1 mole of N2, 2 moles of NH3 are formed. Therefore, for X moles of N2 which is to be reacted, 2 moles of NH3 is formed. Is it clear to you? How did I do it? Any doubt in this part? What did I say? So we started from 2 moles of N2 and 3 moles of H2. I said that the system is in the initial phase. Now it is moving on to the equilibrium phase. Then I said that suppose after equilibrium, after reaching the equilibrium, X moles of N2 is reacting. Okay. Now their respective stoichiometric coefficient will react. So X mole of N2 will react with 3x moles of H2 and it will form 2x moles of NH2. Okay. This is the first thing. Next, what will be the number of moles of NH3 at equilibrium? So it is already given that this equilibrium of NH3 will have 1.62 moles. So we have divided it by the molar mass to get the number of moles. So at equilibrium, it is said that the equilibrium mixture contains 1.62 moles of ammonia. So it is coming from the question. What we are doing is simply dividing by the molar mass. Now, from the situation itself, what we can say that this 2x and this 1.62 is equal. Any doubt in this? First, what we did, we calculated the equilibrium concentration in terms of x. Next, we already know it for the NH3, so we have equated the same. So 2x is the number of moles at equilibrium for NH3. At the same time, 1.62 is given. So we can say that 2x is equals to 1.62. Okay, that means x is equals to 0.81. Is it clear to all of you? So this is very important to understand. Once you know how to do this, you can use it in each and every problem. Okay, all thing is behind your concept building. Okay, you got this. So initially we have 2 moles of N2 and 3 moles of H2. After some time, x moles of N2 reacted. Now the respective mole of H2 will be 3x and the formed respective mole of NH3 will be 2x. Since we have 0 moles initially of NH3, it is given there that we have only nitrogen and hydrogen in the 1 liter vessel initially. Okay, there are no moles of NH3 present. Got it? But after equilibrium is attained, the number of moles of NH3 becomes 1.62 as the mass is given 27.54. Now if you consider 2x as the same, so x will be equals to 0.81. Any doubt in this part? Now if you put the value of that x in this N2, then the number of moles of N2 at equilibrium will be 2 minus 0.81, which is 1.19. As simple as that. And similarly, from that same value of x, you can calculate the number of moles of your H2 will be 3 into 1 minus x. So it is simply 3 minus 3x or 3 into 1 minus x. X value is 0.81, so 0.57. So are you getting the point how I am getting these values? Anyone who has a doubt in this part, you can ask it here. I am giving you some time to think over it. Is it clear to all of you? How did I moved on to this conclusion? So VK, Dhruv, Partham, Varsha. Are you getting the point that I am trying to put here? Anyone who has a doubt in this part? Again, I am repeating my same thing. So initially we have 2 moles of your N2 and 3 moles of H2. We have calculated it from the given mass. Then after equilibrium, suppose x moles of N2 reacted with 3x moles of H2 to give 2x moles of NH3. Now we already know that 27.54 gram of NH3 is present. So we can calculate the moles from there and we can equate it with that. So 2x is equals to 1.62, which gives your x value as 0.81. Just put it in the equation and you will get your number of moles for each of them. Now, next, the equilibrium concentration of N2 will be what? So we got the number of moles, which is 1.19, and the volume is given. So to calculate the concentration, it will be number of moles by volume of the solution. So 1.19 by 1, which is 1.19 molar. Similarly, the H2's concentration will be 0.57 by 1, which is 0.57 m. And lastly, the NH3 concentration, which is 1.62 by 1. So we simply divided each of these moles by their respective volume. So volume will be same for all of them because they are present in the same reaction mixture. So the volume of the overall solution will be the available volume from each of this. Got it? So this will be your equilibrium concentration for N2, H2 and NH3. Now we have to calculate Kc, which is your equilibrium constant. How we'll do it? So Kc will be NH3 whole square. So we are just putting the power equals to the stoichiometric coefficient divided by N2 into H2 whole 3. You put the values here, you will get it as 11.9 mole raised to the power minus 2 liter square, which will be your correct answer. So this was all for today's class. So in few minutes our maths faculty will join you. So this is a very important problem. If you now know how to solve it, if you are getting my point, it will help you to solve many problems because questions are mainly asked from this patterned question only in the JEE examination, or it will be in different way, means something else will be asked rather than this. Okay, I hope that you all are getting my point. So in few minutes our maths faculty will join you. Thank you for joining the session.
Hello students, welcome to JEE 40 days crash course. Today is day 12. So in today's lecture, we will discuss real function. So real function is basically a subtopic of relations and function topic. Okay. So I hope you are ready to start. So let's get started. This is disclaimer. First of all, we will see chapter weightage. So we will discuss trend analysis according to last 5 years. As I told you, real function, this topic is basically subtopic of relation and function chapter. Okay, so main chapter name is relation and function, and here we are going to discuss real function. So first of all, we will see weightage of this chapter in the point of view of JEE, JEE exam. Okay, so the chapter weightage is 2.08%. Very low weightage, despite of low weightage of this chapter, but you don't miss this chapter. Okay, this chapter based on very conceptual questions. Okay, so you can easily solve from this chapter any question that will be easy to do. So now see yearly question distribution. So here we will see in which topic and how many questions asked in JEE main exam. Okay, and we will also see difficulty level. Okay, so see here in 2024 there is no question on this topic. Okay, and in 2023 one question asked best one range of rational function. Okay, there the question asked find the range of rational function. Okay, in 2022 one question asked best one quadratic equation. Okay, so in 2023 difficulty level is average, in 2022 difficulty level is also average. Okay, then in 2021 one question asked one greatest integer function and difficulty level is average. Okay, in 2020 two questions asked best one range of greatest integer function and the difficulty level is difficult. In 2019 one question asked best one range of function and difficulty level is average. Okay, and one question asked in 2018 best one breaking of modulus function and the difficulty level is difficult. So the difficulty level ranges from average to difficult. Okay, so basically in this chapter question asked one range of function or question asked one rational function, quadratic function, okay, greatest integer function, and also you will get question one domain of function. Okay, so let's start. First we will see what we will cover in this lecture. So first of all, see here we will cover real valued function and real function. So do you know about real valued function and real function? Do you have any idea when real valued function and real function? Have you any idea? So first we will discuss real valued function and real function. So what is real valued function? When a function f from a to b, when b is a subset of real numbers, then the function f is called real valued function. Okay, and if a and b both are subset of real numbers, then that function is called real function. So what is the main difference between real valued function and real function? So real valued function, for being a real valued function, only we need b is a subset of real numbers. Okay, but for real function, you need a and b both are real function, both are subset of real numbers. Okay, so this is the common difference of real valued function and real function. So we will discuss about this. After that, we will discuss domain and range of real function. There we will study how to find domain of real function and how to find range of real function. Okay, so you have seen based on domain and range of real function in the JEE exam, many questions asked. Okay, so you should keep in your mind this topic, domain and range of real function, very important topic on this chapter. After that, we will discuss algebra of real functions. So there we will learn how to add two functions to real functions. Okay, how to subtract two real functions, how to multiply two real functions, and how to divide, how to find division of two real functions. There we will learn. After that, we will see equal functions. So when two functions, suppose you have two functions f and g, when they are called equal functions, okay, we will learn about that. So we will discuss about equal functions when we call two functions are equal. Okay, there we will see some conditions for equality of functions. After that, we will see basic functions like identity functions, polynomial functions, quadratic functions, rational functions, greatest integer functions, okay, and etc. So I hope you are with the notebooks and pens ready. So are you ready to start? Today's first topic, real valued function and real function. Are you ready? I hope you are ready with your notebooks and pens. Okay, so you don't forget to take your notebooks and pens. So whatever I will teach you, write down in your notebooks. Okay, that will help you to revise that things. Okay, so let's start today's first topic, real valued function and real function. So first we will discuss real valued function and real function. So do you have any idea of real valued function and real function? Do you know about that? Do you have any idea? Write yes or no in chat section. What is a real valued function and what is real function? Do you know? Okay. Here you can see the function f is defined from set A to set B. Okay. So a function from A to B is said to be a real valued function if B is subset of real numbers. Okay. So for real valued function, here codomain set should be subset of set of real numbers. Okay. So you don't need A is subset of real numbers, but you just need B is subset of real numbers. Okay. So then you will call this function is real valued function. Clear? Suppose you have f of x equals 1 by x. Okay, 1 by x. Is this function real valued function? F of x equals 1 by x. Okay, so if you see here, the function f is defined from interval 0 to infinity to set of real numbers. Okay, so this is a real valued function. Okay, but if both a and b are subset of real numbers, then the function is called a real function. Okay, so f defined from a to b, and if both a and b are subset of real numbers, then f is called a real function. Clear? Do you understand? Can you understand what is real valued function and what is real function? This is very basic concept, and these will help you to understand this chapter. Okay, so don't forget to what is difference between real valued function and real function. Okay, so see here the definition of real valued function and real function. Okay, and see here what is the difference between real valued function and real function. Clear? Is it clear to all of you? I hope it's clear. Okay, now move to the next. Here one note, every real function is a real valued function, but converse need not be true. Why? Why every real valued function is not real function? Why? By definition you can say was you can, okay, you can say a real valued function, for real valued function, a function f from a to b should be subset of real numbers. Okay, but for real function a and b both are subset of real numbers. Okay, that is why any real valued function is not real function, but every real function is a real valued function. Okay, that is why here it said converse need not be true. Clear? Is it clear to all of you? Do you have any doubt in this slide? Okay, I think it's clear to all of you. Now moving to the next topic. So now we will see domain and range of real function. Okay, so first of all we will see definition of domain and range of real function. So what is the definition of domain and what is the range of real function? Write in chat section. Okay, you will know about domain and range of real function. You have studied in relations and function chapter. Okay, so you will know about this. So domain and range of real function you know. So write the definition of domain and range of real function in chat section. Okay, so see here that what is domain? The domain of y equals f of x is the set of all real x for which f of x is defined. Okay, so we will take all those x for those the function f of x is defined. Okay, that values is basically set of all those values is basically a domain of that function. Okay, so the domain of f of y equals f of x is the set of all real x for which f of x is defined. So you can take this example, f of x equals 1 by x. Okay, what is the domain of f of x equals 1 by x? F is defined from close open interval 0 to infinity to set of real numbers. Okay, so f of x equals 1 by x. What is the domain of this function? Write in chat section. What is the domain of f of x equals 1 by x? Can you write it? Everyone write in chat section. What is the domain of f of x equals 1 by x? And also write the domain of f of x equals square root of x. Okay, so it is your homework. The domain, what is the domain of f of x equals square root of x, and what is the domain of f of x equals 1 by x. Okay, everyone try it. Now move to the next. Now we will see range of y equals f of x. So what does it mean range of y equals f of x? So range of y equals f of x is collection of all distinct images corresponding to each real number in the domain. Okay, so you know domain of function f of x. Okay, so if we now find their corresponding images and if we write that in as a set, then you will get the range of that function. Okay, good. Yes, domain of y equals 1 by x is set of real numbers minus singleton 0. For x equals 0, the function y equals 1 by x is not defined. That is why the domain of the function y equals 1 by x is set of real numbers minus singleton 0. And what is the domain of y equals square root of x? So you will know if we have square root of something, okay, so something should be greater than equal to 0. Okay, so the domain of f of x equals square root of x is basically x is greater than equal to 0. That means close interval 0 to infinity is the domain of the function f of x equals square root of x. Clear? And here we studied range of y equals f of x. So range of y equals f of x is collection of all distinct images corresponding to each real number in the domain. Okay, so note here the function f from a to b, then a will be the domain of f and b will be the codomain of f. Okay, so a is called domain of the function f and b is called codomain of function f. Clear? Now how to find range of a function? Suppose you have a function y equals f of x. Okay, so there in question it will ask to find the range of function. Okay, range of some particular function. So for that case, how to find range of function, that we will learn about. Okay, so first of all, find the domain of y equals f of x. So first task you have to find the domain of y equals f of x. Okay, so domain of y equals f of x is basically the set of all real x for which f of x is defined. Clear? Then if domain has finite number of points, okay, so if domain has finite number of points, then range is the set of f images of these points. Okay, suppose your domain is set 1, 2, 3. Okay, and your function y equals f of x. So that case the range of that function will be set f of 1, f of 2, f of 3. Okay, so this will happen only domain has finite number of points. Okay, next, if domain is set of real numbers or set of real numbers minus set of some finite points, then that case you have to express x in terms of y, and then you have to find the value of values of y for which the values of x lie in the domain. Okay, so suppose you have the function y equals f of x equals 1 by x. Okay, so y equals 1 by x, what is the domain of y equals 1 by x? So as we told you, the domain of y equals 1 by x is set of real numbers minus singletons at 0. Okay, so in this case you have to first express x in terms of y. So you have y equals 1 by x, so you can write x equals 1 by y. Okay, and x equals 1 by y, so 1 by y is defined for all those values except y equals 0. Okay, so the range of the function of y equals 1 by x is also set of real numbers minus singletons at 0. Okay, clear? Now if domain is a finite interval, suppose your domain is finite interval, closed interval a comma b or open interval a comma b. Okay, that case you have to find the least and the greatest values for range using monotonicity. Okay, monotonicity means increasing or decreasing. Okay, so if domain is a finite interval, then you have to find least and the greatest values. Clear? I think it's clear. And do you have any doubt? It's clear to all of you? Do you have any doubt? Very simple thing, concept. Okay, first we learn domain of the function, then we learn range, what is range of function. Okay, and then we see here what is the method, what is the method to find range of a function. Okay, so I think it's clear to all of you. Now move to the next. Now we will talk about algebra of real functions. Okay, so first let the function f from x to r and function g from x to r. Okay, so f from x to r and g from x to r be two real functions, both are real functions. So what is the definition of real functions? So if f from a to b and f from a to b is called real function if a and b both are subset of real numbers. Okay, so in this case x and set of real numbers both are subset of real numbers, so f and g be two real functions. Okay, so we let here f from x to r and g from x to r be two real function. Then the sum f plus g from x to r defined as f plus g of x equals f of x plus g of x. Okay, so when you have two real function and their domain are equal, same, okay, then you can define sum of f and g as f plus g of x equals f of x plus g of x. Clear? Next, the difference. So f minus g defined from x to r and defined as f minus g of x equals f of x minus g of x. Okay, this is how we can define difference of two functions. Then the product f into g from x to r defined as f into g of x equals f of x into g of x. Okay, this is how we can define product of two real functions. Clear? Then f plus g and f into g are defined only if f and g have the same domain. So when f plus g and f into g are defined, they are defined only if f and g have the same domain. Okay, in this case you can see f from x to r and g from x to r. Okay, they have same domain. Okay, so that's why f plus g and f into g are defined. Okay, so in case the domain of f and g are different, then what will be the domain of f plus g or f into g? So when the domain of f and g are different, then domain of f plus g or f into g equals domain of f intersection domain of g. Okay, so when domain of two functions are different, then addition the sum of those function, okay, sum of those function or product of those function is basically intersection of their domain. Clear? Then the product cf from x to r defined as cf of x equals c times f of x, where c is a real number. Then here you can see f divided by g. This type of function is called quotient function. Okay, so quotient. So the quotient f by g is a function defined as f by g of x equals f of x divided by g of x. Here provided g of x is not equal to 0 and x is belongs in set x. Okay, so the quotient f by g is a function and it defined as f by g of x equals f of x divided by g of x. And here you note this point, g of x is not equal to 0. Okay, when you take g of x is 0, then that case f of x upon 0 will not define. Okay, that case this quotient function will be undefined. Okay, that's why here we should provide it g of x is not equal to 0 for x belongs in set x. Okay, then if domain of y equals f of x and y if equals g of x are d1 and d2. So d1 is domain of y equals f of x and d2 is domain of y equals g of x. Okay, so then what will be the domain of f of x plus minus g of x? The domain of f of x plus g of x is basically the intersection of the domain of f and domain of g. Okay, and what will be the domain of multiplication of f of x and g of x? What will be the domain of the product of f into g? Similarly, the domain of f into g, f of x into g of x is in d1 intersection d2. Okay, now now I am asking you what will be the domain of f of x upon g of x. Okay, write in chat section what will be the domain of f of x and g of x. Here you can see we have, and try to think how we obtain here domain of f of x upon g of x. Why this type of domain we obtain for the function f of x upon g of x. Okay, write in chat section why we write like this, why we subtract here this set x from x such that g of x equals 0. Why? So here we define quotient f by g is a function defined as f by g of x equals f of x divided by g of x. Okay, and here provided g of x is not equal to 0. Okay, so for g of x equals 0, this function is not defined. Okay, that's why here we subtract from the intersection of d1 and d2 this set x such that g of x equals 0. Okay, So we will subtract all those x. For that, g of x is 0. Okay. So the domain of f of x divided by g of x is d1 intersection d2 minus of set x such that g of x equals 0. Okay. Now take this example. You have f of x equals square root of x and g of x equals 1 by x. Okay. So now find the domain of f of x plus minus g of x and find domain of f of x into g of x, and also find domain of f of x divided by g of x. So you have f of x equals square root of x and g of x equals 1 by x. So everyone write the answer. What will be the domain of f of x plus minus g of x and f of x into g of x? Okay, and what will be the domain of f of x divided by g of x? Everyone write in chat section. What will be the domain for f of x plus minus g of x if your function f of x is square root of x and g of x equals 1 by x? Everyone write in chat section what will be the domain for f of x plus minus g of x or f of x into g of x. Everyone write, and also write the domain of f of x divided by g of x. Write your answer. Everyone write what will be the domain of f of x plus minus g of x or f of x times g of x. Okay, and also find the domain of f of x divided by g of x. You have the function f of x is square root of x and g of x equals 1 by x. Okay, everyone try and write your answer. What will be the domain of f of x plus minus g of x? Write in chat section. First find the domain of f of x equals square root of x. Okay, and find domain of g of x equals 1 by x. Here we asking to find the domain of f of x. To find we are asking to find for function f of x equals square root of x and g of x equals 1 by x. Okay, here I am asking to find the domain of f of x plus minus g of x or f of x times g of x for f of x equals square root of x and g of x equals 1 by x. Everyone write your answer. So if domain of f of x is d1 and domain of g of x is d2, that case d1 intersection d2 is the domain of the function f of x plus minus g of x or f of x times g of x. But here you have the function f of x equals square root of x and g of x equals 1 by x. Right, for that function. So everyone try it. No wrong. F of x, domain of f of x is what? Domain of f of x equals square root of x is basically close 0 open infinity. Okay, and domain of g of x equals 1 by x is basically open interval 0 singleton 0, sorry, subtract singleton 0. Okay, from set of real numbers. So domain of g of x is set of real numbers minus singleton set 0. Okay, and now what is the intersection of the close 0 to infinity and set of real numbers minus singleton set 0? So what is that intersection? The intersection will be open interval 0 to infinity. Okay, so the domain of f of x plus minus g of x or f of x times g of x is open interval 0 to infinity. Yes, good, your answer is correct. And similarly you find domain of f of x divided by g of x for f of x equals square root of x and g of x equals 1 by x. Clear? Now moving to the next. Now we will talk about equal functions. So when two functions f and g are said to be equal, so two functions f and g are said to be equal if the domain of f equals the domain of g. Okay, this is first condition. The second condition is the range of f is equal to the range of g, and the third condition is f of x equals g of x for while x belongs in domain. Okay, so these are three conditions to being equal of two functions. Okay, two functions f and g are said to be equal if the domain of f equals the domain of g, and the range of f equals the range of f g, and f of x equals g of x for while x belongs in domain. Clear? I think it's clear. So for example, you can take the function f of x equals x plus 1 whole squared. Okay, and also take here the function g of x equals x squared plus 2x plus 1. Okay, so f of x equals x plus 1 whole squared and g of x equals x squared plus 2x plus 1. So are they equal? F of x and g of x are equal? Yes or no? Your f of x is x plus 1 whole squared and g of x is x squared plus 2x plus 1. Are they equal or not? Everyone write yes or no. Are they equal? F of x equals x plus 1 whole squared, g of x equals x squared plus 2x plus 1. Okay, you have two functions f of x and g of x, and now you have to check equality of these functions. Are they equal or not? Okay, so how to check? So for that you have to first check domain of function f and domain of function g. Okay, so you have f of x equals x plus 1 whole squared and g of x equals x squared plus 2x plus 1. So both are positive for all x. Okay, so domain of the function f of x and domain of the function g are equal. Okay, you can say, and here you can see for all x belongs in set of real numbers, f of x equals x plus 1 whole squared and f of x equals x squared plus 2x plus 1. Okay, has pre-images. Okay, so actually has images. Okay, so for every x belongs in set of real numbers have images. So range of the function f and the range of the function g are both equal to set of real numbers, so both are equal. Okay, and you can check by expanding f of x equals x plus 1 whole squared. This is equal to basically x squared plus 2x plus 1. Okay, and you can see for all x belongs in domain, x plus 1 whole square, this is equal to x squared plus 2x plus 1. So f of x function is equal to the function g of x. Okay, so both function for all x belongs in domain, f of x equals g of x. So all these three conditions satisfied, so we can say f of x equals x plus 1 whole squared and g of x equals x squared plus 2x plus 1 are equal functions. Okay, clear? I hope it's clear to all of you. Now moving to the next. Now we will talk about an important topic when this chapter is inverse functions. Okay, very crucial chapter, very important chapter. Okay, and very crucial topic here, inverse functions. So when we say inverse of any function exists, okay, and if inverse of any function exists, then how many inverse of any function you will get? Okay, one or more than one. It's your question. So here see, the function f from a to b is a bijective function. Which type of function f here? F is here bijective function. You will know about bijective function. Okay, when we say two function when we say a function is bijective, when a function is 1 1 and 1 2, okay, both, then the function is called bijective. Clear? So if f from a to b is a bijective function, then the mapping, here you can see this function, it defined from b to a, and which associate each element b from set b to a unique element a from set a, such that f of a equals b, f of a equals b, and is called the inverse of function f. Okay, this mapping is called the inverse of function f. Clear? So mathematically you can say f inverse of b equals a if and only if f of a equals b. Clear? Now see, the curves of y equals f of x and y equals f inverse of x are mirror images of each other in the line y equals x. Okay, so if you take y equals x line, okay, and you have a function like this. Okay, so if you take mirror image of this function, then you will get the inverse of that function. Clear? This is the one process to find the graph of inverse of a function. Okay, so you have y equals f of x and take the mirror image of y equals f of x in the line y equals x, then you will get y equals f inverse, graph of y equals f inverse of x. Okay, clear? So the curves y equals f of x and y equals f inverse of x are mirror images of each other in the line y equals x. Clear? I think it's clear. Okay, very simple result. Okay, now see, when we say an function is invertible, so a function f is invertible if and only if the function f is 1 1 and 1 2. Okay, 1 1 and 1 2, then the function is invertible. So when you can say a function is invertible, if you can say the function is 1 1 and 1 2, then you can show the function is invertible. Or if the function f is invertible, then you can say the function f is 1 1 and 1 2. Okay, both side implication use here, if and only. So inverse of bijective function is unique and bijective. So inverse of bijective function is unique. That means inverse of any function is always one and single one. Okay, there is there is no two function of any inverse of any function any functions. Okay, that is only unique. Okay, only one you will get inverse function. So inverse of bijective function is unique and inverse of bijective function is also bijective. That means inverse of bijective function is 1 1 and 1 2. Clear? Then see, the solution of f of x equals f inverse of x are same as the solution of f of x equals x. Okay, both are same. So in solution of f of x equals f inverse x and solution of f of x equals x, both are same. And when you have f of x equals x, then these points x are called fixed point. Okay, note this point, x, when you have f of x equals x, then the point x are fixed points. Here you can see here f composition g is identity function equals g composition f, then f and g are inverse of each other. Okay, this is another way to show to find the inverse of any function. Okay, so if you have a function f and you want to find the inverse of that function, just take composition of those. Okay, and so the composition of that two functions is identity function, then you can say both are inverse to each other. Okay, so here you can see f composition f inverse is basically equals identity function in B set, and f inverse composition f is equal to identity function in set A. Okay, and inverse of inverse function is basically original function. So if you take inverse of inverse, then you will get the function f. So f inverse of inverse equals f. So if f and g two bijective functions, that means f and g are both 1 1 and 1 2, such that g composition f is exist. Okay, g composition f is exist, then g composition f is also bijective function. So f and g are two bijective functions, then you can say composition of those functions is also bijective function. Okay, so f and g are two bijective functions such that g composition f is, if g composition f exists, then g composition f is also bijective function, and you can define the inverse of this function, g composition f of whole inverse equals f inverse composition g inverse. Okay, so this is very important, g composition f whole inverse equals f inverse composition g inverse. Okay, clear? And here f inverse whole inverse equals f. These are two very important concept, one inverse or inverse functions. Clear? I hope it's clear to all of you. Now move to the next topic. Now we will talk about basic functions. So there are some basic functions, one real function. So basic functions can be categorized in the following categories. Okay, so first category is algebraic function. So when a function is called algebraic function, So a function, say f of x, is called an algebraic function if it consists finite number of terms involving powers, roots, okay, of the independent variable x, and the four algebraic operation used: plus, minus, multiplication and division. So algebraic function consists finite number of terms involving powers and roots of the independent variable x, and the four algebraic operations: plus, minus, multiplication and division. Clear? Very simple. Now we will see some algebraic functions, okay, that are given in below. So first algebraic function, polynomial function. So when we say a function is polynomial, so the function f of x equals a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus an minus 1 times x plus an. Okay, so this type of function is called polynomial function. And here what we say, a naught, about a naught, a1, a2, an. Okay, so where a naught, a1, a2 dot 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 up to an are real numbers, okay, are real numbers, and here n belongs in set of natural numbers, and this function is known as polynomial function. And if a naught is not 0, so that means the coefficient of x to the power n is not 0, then n is the degree of the polynomial function. Okay, so when a naught is not 0, then degree of the polynomial function f of x is n. Now see, what is the domain of polynomial function? The domain of polynomial function is set of real numbers. For all the set of real numbers, the polynomial function is defined. So for all values of x belongs in set of real numbers, the function polynomial function f of x is defined. That is why domain of polynomial function is set of real numbers. And what is the range of polynomial function? So a polynomial function of odd degree, when n is odd, okay, that case the range of polynomial function is minus infinity to infinity, that is set of one real numbers. Okay, but a polynomial of even degree has a range which is always subset of real numbers. Clear? Now see another algebraic function, that is constant function. Okay, so the function f of x equals k, where k is constant, is known as constant function. So when you have function like this, f of x equals k, where k is constant, then this type of function is known as constant function. And what is the domain of this function? The domain of this function is set of real numbers. For all x belongs in set of real numbers, this function is defined. Okay, so that is why the domain of f of x equals k is set of real numbers. And what is the range of function f of x equals k? The range of the function f of x equals k is singleton set k. Okay, whatever you give input here, you will get only k. So in range set, you will get just k. That is why the range of the function f of x equals k is singleton set k. And see here another algebraic function, that is identity function. So the function f of x equals x is known as identity function, and its domain is set of real numbers and range is set of real numbers. Clear? Now see rational function. So the function f of x equals p of x divided by q of x, where p of x and q of x are polynomial functions and q of x is not 0, is called rational function. So what is the domain of rational function? Domain of rational function is set of real numbers minus the set x such that q of x is 0. And what is irrational function? The algebraic functions containing one or more terms having non-integral rational power of x are called irrational functions. Okay, for example, you can take y equals f of x equals 2 times square root of x minus cube root of x plus 6. Reciprocal function, the function f of x equals 1 by x is called the reciprocal function of x. Okay, and domain of this function 1 by x is set of real numbers minus singleton set 0, and range is also set of real numbers minus singleton set 0, as I told you before. Okay. Now we will see here what we have studied in today's lecture. Okay. So first we discussed about real valued function. So we talk about real valued function. What is real valued function? And we've also discussed real function. And we've also discussed a domain and range of real function. There we learn what is the definition of domain, okay, and how to find domain of any function. And then we study, we have studied range of function. Okay, what is range of function? How to find range of y equals f of x function. Okay, and we have studied algebra of real functions like addition, subtraction, multiplication, division, etc. And we have studied equal functions. Two functions f and g are considered equal if they have the same domain and produce the same output for every input in the domain, and f of x equals g of x for all x in the domain of f and g. And we have learned some basic functions like linear functions from f of x equals mx plus b, where m is the slope and b is the y-intercept. And quadratic function, the form of quadratic function is f of x equals ax squared plus bx plus c, and important vertex and axis of symmetry can be calculated. And polynomial function form f of x equals an x to the power n plus an minus 1 x to the power n minus 1 plus dot 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 plus a1 x plus a naught. Here important can have various shapes depending on the degree of n. And rational function form f of x equals p of x by q of x, where p and q are polynomials. Here important domain excludes values that make q of x is 0. And exponential function, the form of exponential function is f of x equals a times b to the power x, where b is greater than or equal to 0. Important models growth or decay processes. Logarithmic function form f of x equals log base b of x. Important, the inverse of the exponential function this is. And trigonometric functions, example sin x, cos x, tan x. Okay, and important periodic functions used in various applications. Okay, that's we learned today's in theory session. Now we will discuss practice questions. So wait a minute. Okay, students, now we will practice some questions on real functions. So first see here question number 1. So here in this question you have two sets a and b. Okay, and a defined as a equals set of order pairs x comma y such that y equals e to the power 2x and x belongs in set of real numbers. And the set b defined as the set of all those order pairs x comma y such that y equals minus x squared and x belongs in set of real numbers. Okay, and then you have four options. In first option you have a subset b, in second option you have b subset a, in third option you have a union b equals a, in fourth option you have a intersection b equals 5. Okay, so which option is correct here you have to find. So first of all, try it by yourself and take your time. So everyone do it. which option is correct here? Which option is correct here? Write your answer in chat section. Everyone try it. Do it. Which option? Just you have to draw the graph of y equals e to the power 2x and y equals minus x squared. Okay, and then find the intersection points of these two graphs. Okay, so find the number of points of a and b. Okay, so here first draw the graph y equals e to the power 2x and then draw the graph of y equals minus x squared and write your answer in chat section which option is correct. Everyone do it. Do it by yourself first, then we will discuss the solution. Everyone do it. Which option correct? Quickly do it. Try it. I've given you hint. Just draw the graph of y equals e to the power 2x and y equals minus x squared and find the intersection point. Which option is correct? Right? Everyone, write in chat section. Are you got your answer? Yes, good. Here one said option D is correct. Okay, so let's see which option is correct here. Answer is option D. So correct answer is option D. Now see how we obtain option D. Okay, so let's start the solution. Here you can see set A represents the set of points lying on the graph of an exponential function. That means the graph of y equals e to the power 2x. Okay, and here the set B represents the set of points lying on the graph of the polynomial y equals minus x squared. Okay, so here if you draw the graph of y equals e to the power 2x, then you will get like this. Okay, you will get this get like this graph, and if we draw the graph of y equals minus x squared, then you will get like this. So here you can see e to the power 2x and minus x squared. So when you take e to the power 2x equals minus x squared, then the two curves does not intersect. Okay, they never intersect to each other. Hence, there is no common point between them. Okay, that is why A intersection B is empty set. Clear, everyone? It's clear to all of you? Very simple question. I hope it's clear to all of you. Now moving to the next. So let's look at question number 2 here. Here you have given the function f of x equals square root of sine inverse of 2x plus pi by 6 for real value of x. Okay, and you have to find domain of definition of this function. So first of all, try it yourself and write which option is correct. You have here 4 options. Among these 4 options, which option is correct? Write in chat section. Okay, try it by yourself first and take your time. Everyone do it. Everyone do it. Which option? Very simple. Okay, but just you have to write sine inverse 2x plus pi by 6 is greater than equal to 0, and then use some basic concept and find the domain of definition of this function. Okay, so which option is correct here? Right, everyone, write your answer. Everyone do it. You can do it. Very simple question. Very easy question. Which option is correct here? Just use this concept. If you have an expression within square root of something, okay, square root, if square root of something, then something should be greater than equal to 0. Okay, use this concept and find which option is correct here. So one said option D. So let's check which option is correct here. So answer is option A. Okay, option A is here the correct answer. So who said option D? That is incorrect answer. Okay, don't worry, I will say you how we obtain the option A. Okay, so let's start the solution. So for f of x to be defined, what we have to do? We have to take sine inverse of 2x plus 5 by 6 is greater than equal to 0. Okay, so you know, if we have square root of expression, okay, square root of some expression, then that expression should be greater than equal to 0. Okay, so for define f of x, sine inverse of 2x plus 5 by 6 should be greater than equal to 0. And you know, range of sine inverse of x, okay, so sine inverse 2x will lies between minus pi by 2 to pi by 2, but here you said sine inverse of 2x plus pi by 6 is greater than equal to 0. So from here you get sine inverse of 2x is greater than equal to minus pi by 6. Okay, so now you can bounds sine inverse of 2x between minus pi by 6 and pi by 2. Okay, so you will get this inequalities, minus pi by 6 less than equal to sine inverse of 2x less than equal to pi by 2. Clear? Now what you have to do? So now take sine function on both sides. Then you will get sine of minus pi by 6 less than equal to 2x less than equal to sine of pi by 2. Okay, so what is the value of sine of minus pi by 6? And what is the value of sine of pi by 2? So the value of sine of minus pi by 6 is minus 1 by 4, and sine of pi by here you can find sine of minus pi by 6, okay, and find sine of pi by 2, then divide by 2. Okay, sine of minus pi by 6 is minus 1 by 2 and sine of pi by 2 is 1, and by dividing 2 you will get minus 1 by 4 less than equal to x less than equal to 1 by 2. Okay, clear? So x belongs in closed interval minus 1 by 4 comma 1 by 2. Okay, this is in option A. So the correct answer is option A. Is it clear to all of you? Do you have any doubt? I hope you have no doubt. Very simple. We have done here step by step. Okay, and we use very basic concept. So I think it's clear to all of you. Now moving to the next question. So now let's look at question number 3. So what we have to do in this question? So in this question we have f of x equals 1 divided by square root of mod of x minus x. Okay, and we have to find domain of this function. Okay, so how to find domain of this function? Everyone try it. You have 4 options, so you have to choose the correct answer from the given options. So which option is correct here? Everyone do it and write your answer in chat section. Which option is correct here? Okay, Kuldeep, you give your answer B. Okay, so let's see the answer. Which option is correct here? So answer is option B. Okay, correct answer is option B. So everyone match with your answer. And now let's see the solution step by step. So you have f of x equals 1 divided by mod of x minus x. Okay, and you can write y equals 1 divided by square root of mod x minus x. Clear? Now for domain, mod of x minus x should be strictly greater than equal to 0. Okay, mod x minus x should be greater than 0. It never be equals 0 or less than 0. Okay, so mod x minus x is greater than 0, not equal. Okay, strictly greater than 0 for defining y equals 1 divided by square root of mod x minus x. Clear? So from this inequality, you can write mod x is greater than x. So when it happens, can you answer? When it happens, mod x is greater than x. Is it fault for x equals 2? No. If we take x equals 2, then 2 mod of 2 is 2. Okay, is not strictly greater than 2. So it's not possible for positive values of x. Okay, it's only possible when you take the value of x is negative. Okay, if you take x equals -1, then it hold. If you take x equals -2, then it also hold. Okay, so mod x is greater than x. This only hold when you take x is negative. Okay, that means x should be belongs to -infinity to 0. So this is only possible if x is negative, therefore x belongs in open interval -infinity to 0. Okay, so this is the domain of the function f of x equals 1 divided by mod of x minus x. Clear? I think it's clear. And now moving to the next. In this question, we have the function f of x equals 3 divided by 4 minus x squared plus log base 10 of x cube minus x, and we have to find domain of definition of this function, and we have given here 4 options. So you have to find which option is correct here. So everyone do it. So try it by yourself first and take your time. Everyone do it. Which option is correct here? Everyone do it. Which option? Right here. Which option is correct here? Do it. Are you trying to do it? Okay, do it. Okay, you are saying option D is your correct answer. So let's check which option is correct here. So answer is option D. Yes, correct answer is option D. So now see how we obtain the correct answer is option D. Let's see the solution step by step here. So you have given here g of f of x equals 3 divided by 4 minus x squared plus log base 10 of x cube minus x. Okay, so for domain of f of x, x cube minus x should be greater than 0. So for defining log of log function, here this number x cube minus x should be greater than 0. Okay, so x cube minus x is greater than 0. So from here we will get this inequality x times x minus 1 times x plus 1 is greater than 0. Clear? And by putting these values on number line, you will get the where in which intervals x lies. So here you can check by Webicop method. So x belongs in interval -1, 0 union 1, infinity. And here defining this function, 4 minus x squared should not be 0. Okay, so 4 minus x squared is not equal to 0. It implies x is not equal to plus and minus 2. So now it implies x belongs in -infinity to -2 union -2 to 2 union 2 to infinity. Okay, so you can see here. So the region is -1, 0 union 1, 2 union 2, 2, infinity. Okay, you can see here this graph. Okay, this diagram, and here the correct answer is option D. So I hope it's clear to all of you. Very simple question. Okay, now moving to the next question. Now let's look at question number 5. So in question number 5, you have function f from R to R. Okay, the function f defined from set of real numbers to set of real numbers, and this function is satisfying the property f of x plus 1 plus f of x plus 3 equals 2 for while x belongs in set of real numbers. Then we have to check, is this function periodic, or what will be the period of this function. Okay, if this is not periodic, then we will say non-periodic function. Okay, so check which option is correct here. Okay, so everyone write your answer in chat section. So try it by yourself first. Everyone do it. Very simple question, just you have to do some algebraic manipulation. Okay, and you will get the answer. So everyone do it. Which option is correct here? Try it. Quickly do it. Which option is correct here? Everyone do it and give your answer. Write your answer in chat section. Everyone do it. Which option? So one said option B is here the correct answer. Okay, so let's see which option is correct here. Yes, the correct answer is option B. Okay, so option B is here the correct answer. So now we will see how to find here why option B is your correct answer. Okay, so let's start the solution step by step here. So we have f of x plus 1 plus f of x plus 3 equals 2. Okay, so everyone write this equation, equation number 1. And now on replacing x by x plus 2, so in place of x, now we will write x plus 2. Then we get f of x plus 3 plus f of x plus 5 equals 2. Clear? Now write this equation, equation number 2. Now on subtracting equation 2 from equation 1, so subtract equation 2 from equation 1, then what you will get? Then we get f of x plus 1 minus f of x plus 5 equals 0. Okay, here f of x plus 3, this term will be cancelled to each other because you have plus f of x plus 3 and minus f of x plus 3, so they will be cancelled to each other, and you will get this equation f of x plus 1 minus f of x plus 5 equals 0. Clear? Now you can write this equation as f of x plus 1 equals f of x plus 5. Okay, so f of x plus 1 equals f of x plus 5. So now what you have to do? So now on replacing x by x minus 1, we get here f of x equals f of x plus 4. Okay, so f of x equals f of x plus 4, and we will know the definition of periodic function. So when we say a function is periodic, can you say when a function is called periodic function and what is the period of that function? Can you say? So a function f is called periodic function if there exists a number t for that f of x plus t equals f of x. Okay, and here this number t is called period of function f. So here you can say, you can see here f of x equals f of x plus 4. Okay, and here you can take t equals 4. So here f of x equals f of x plus t. So f of f function is periodic function, and here the period of this function is 4. Hence the function f is periodic with period 4. Clear? This is the final answer, and our correct answer is option B. So I hope it's clear to all of you. Very simple. Okay, just we do some algebraic manipulation and then we solve 2 equations and get the relation. Okay, and then by replacing x by x minus 1, we get this equation f of x equals f of x plus 4, and from this we say f function is periodic with period 4. So now moving to the next. So in this question we have f of x equals sine cube x plus cos cube x, and you have to find the period of this function. So everyone find its period. Okay, so you have 4 options. So which option is correct here? So first of all, try it by yourself and write your answer in chat section. So everyone do it. Take your time and do it and write your answer in chat section. Which option is correct here? Everyone do it. Very simple. Just you have to use trigonometric formula. Okay, use sine 3x formula and use cos 3x formula. Okay, and you use some basic concept and you will get the answer. Okay, which option is your correct answer? You will get the answer. Okay, so here one said option A. Okay, so let's check the let's check which option is correct here. Yes, the correct answer is option A. Okay, so now check how to find period of function f of x equals sine cube x plus cos cube x. So let's start the solution. So first use sine cube x can be written as 3 sin x minus sine 3x by 4 from sine 3x formula. Okay, and you can write cos cube x as 3 cos x plus cos 3x by 4. Clear? You can write it. And you know, if we have sum of any function or difference of functions, then period of that function is basically LCM of period of those sum of functions. Okay, those functions. So here therefore period of f of x is basically LCM of period of sin x, cos x, sin 3x, cos 3x. Okay, so first you need to know period of sin x, cos x, sin 3x and cos 3x. So what is the period of sin x? Can you say what is the period of sin x? What is the period of cos x? What is the period of sin 3x? And what is the period of cos 3x? Everyone write in chat section. What is the period of sin x, cos x, sin 3x and cos 3x? Everyone write. What is the period of sin 3x? What is the period of sin 3x? What is the period of cos 3x? Everyone do it. So first we need to find period of sin x, cos x, sin 3x, cos 3x. Good. Yes. Period of sin 3x is 2 pi by 3 and period of cos 3x is also 2 pi by 3. Okay. Now you have to find LCM of period of sin x, cos x, sin 3x and cos 3x. So you can here see else you just find LCM of 2 pi comma 2 pi by 3. Okay, and LCM of 2 pi comma 2 pi by 3 is equal to the LCM of 2 pi comma 2 pi divided by HCF of 1 comma 3. Okay, so when you have numbers like fractions a comma b, a by b, a1 by b1, okay, then LCM of a by b comma a1 by b1 is equal to LCM of a comma a1 divided by HCF of b comma b1. Okay, so period of f of x equals LCM of 2 pi comma 2 pi divided by HCF of 1 comma 3. Okay, so LCM of 2 pi comma 2 pi is 2 pi and HCF of 1 comma 3 is 1. So period of f of x equals 2x, 2 pi. Okay, so 2 pi, the period of the function f of x equals sine cube x plus cos cube x. So correct answer is option A. So I hope it's clear to all of you. That's all for today's lecture. Thank you for your attention. I hope this lesson was helpful to all of you. Hello students, in today's lecture we are going to learn about gravitation, and this is theory part 2. This is our disclaimer. So in today's lecture we will cover first Kepler's laws of planetary motion. After that we will discuss gravitational potential energy. Then we will learn escape velocity, then satellites. All right, so these are the important concepts for the exam. So our first concept is Kepler's laws of planetary motion. So Tycho Brahe, uh, he was a scientist, observed that the motion of planets, all right, and he was collected some data about planetary motion, all right, and that data was analyzed by Kepler, who proposed three laws about planetary motion, all right. So uh, we have three laws. Okay, we will learn each law one by one, and these laws are very important for the exam. Okay, everyone. So first law is known as law of orbits. This law tells us about the orbits. So according to this law, uh, we can say all the planets move around the sun in an elliptical path. Okay, with the sun at one of the foci of the ellipse, meaning that whether it's Earth or Mars, the revolving path of all planets around the sun will be elliptical. And another important point is that this planetary motion occurs under gravitational force. Look at figure here. This one, this trajectory is a elliptical. Okay, not circular, elliptical. So all planets move around the sun in an elliptical orbit with the sun at one focus of the ellipse. So this one is the focus of the ellipse. An ellipse has two foci. Okay, so within an ellipse there are two perpendicular axes, one uh, larger one and one smaller one. So the larger axis is called semi major axis. So this axis is larger axis or known as semi major axis, and other one is minor axis. So this is the minor axis. Okay, everyone. If we consider their half parts, they are called semi major and semi minor axis of the point closest to the sun. Okay, as shown in the figure. So from perihelion, from this point to this central point is the semi major axis, and if we talk about the semi minor axis, from this point to this point. Okay, So here question arises, what is perihelion and what is aphelion? Yes or no? So if we talk about the perihelion, so we can say the point closest to the sun is called perihelion. And if we talk about the aphelion, so we can say the point furthest away from the sun. Okay, so these 2 points are very important, perihelion and aphelion. So this is the Kepler's law of orbits. The second law, known as law of areas. So the line joining the sun to the planet swipes out equal areas in equal intervals of time. That is, aerial velocity of the planet with respect to sun is constant, and this is called the law of area, which indicates that a planet moves faster near the sun and slowly when away from the sun. This is very important law, and we will understand it in detail. Okay, so according to law, planet sweeps out equal areas in equal intervals of time. Okay, so this is our statement. So the aerial velocity of the planet will be constant. Aerial velocity means the area swept per unit time. To observe the area swept, we need to look at the planet's position vector. So the area formed by this position vector will be the area swept by the planet. Okay, everyone. So as you can see in the figure above, in this figure, okay, the shaded area is the swept area swept. This one, the shaded area is area swept. So from this law, it is concluded that the speed of the planet at perihelion, at here, this is the perihelion, is higher compared to the speed of the speed at the aphelion point. Okay, so these 2 points, perihelion and aphelion. So at this point, the speed of the planets is high, and at this point, the speed of the planet is low. So first thing you need to keep in mind is that this planetary motion occurs under a central force. So the torque about the sun point becomes zero. Therefore, angular momentum is conserved in this. And due to the conservation of angular momentum, it becomes a planar motion, meaning planets revolve in a two-dimensional motion. Okay, everyone. So this is all about the law of areas. In short, we can say planet swipes out equal areas in equal intervals of time. Clear? Now here, one question for you. Suppose the planet having at perihelion, okay, at this point. So in that case, what will be the kinetic energy? Think about it. And at point at the aphelion, okay, in that case, what will be the kinetic energy? Think about it and tell me the answer. You have to find out the kinetic energy at 2 points. First at the perihelion, second at the aphelion. So as we know, at the perihelion, planets move with high speed. So we can say that their kinetic energy will be high. And at aphelion, planets revolve slowly. So in that case, their kinetic energy will be less as compared to perihelion. Okay, everyone. Kinetic energy never be negative. It should be always positive. Okay. Now, let's see third law known as law of periods. So, according to this law, the square of the planet's time period of revolution is directly proportional to the cube of semi-major axis of its orbit. This means that if the planet's time period of revolution is capital T and A is the semi-major axis, okay, you know A, this one, this is the semi-major axis. So, law of periods mathematically we can write T square is directly proportional to AQ. Okay, so A is the semi major axis. The greater the value of A, the greater will be the time period of revolution capital T. Okay, so this is the law of periods. So these three laws are very important for the exam. I hope this is clear. Yes or no, everyone? Any doubt here? Now we will understand gravitational potential energy. Now since the this motion is occurring under the gravitational force, which is a conservative force, gravitational force is a conservative force, so we can define potential energy corresponding to this force, which will be called gravitational potential energy. So here we can understand this in terms of work done. So the gravitational potential energy of a body or system is negative of work done by a conservative gravitational force F in bringing it from infinity to present position. Mathematically, we can write the gravitational potential energy denoted by capital U is equal to minus of W, which is equal to minus integration uh, infinity to that point, and that point is R, F dot dr. So you can also understand it this way to that the amount of work done by an external agent in bringing a mass from infinity to a point in this space will be potential energy of that mass at that point. So this relationship is very important. Now suppose that we only have two masses, m1 and m2, okay, in space. Then gravitational potential energy of two particles of masses m1 and m2 separated by distance small r is given by u equal to minus g m1 m2 divided by r. We can show this thing through calculation. Okay. So suppose initially two masses are separated by an infinite distance. If you fix one mass at its location and bring the other mass from infinity to a radial distance small r from the first mass, then you will have to do this much work. So now if we take one body out of the two masses as earth, to gravitational potential energy of a mass m at the surface of the earth will be u equal to minus g capital M into small m divided by r. Okay, so here mass of the earth is capital M and r is the radius of the earth. Okay, everyone, these formulas are clear, I think. Yes, yes or no? If yes, please write in the chat box. Okay, very good. Now if we consider 2 points, one at a height small h from the earth's surface and other on the earth's surface, okay, then the difference in potential energy at these 2 points will be u of r, r plus h minus u of ur. So here this is the potential energy. Okay, this is the potential energy at height h, and this is the potential energy ur at the earth surface. So the formula of the potential energy at a height h, it will be minus uh, in capital G into capital M into small m divided by r plus h minus gravitational potential energy at the earth surface. So it will be gmm divided by r. Okay, so this is the difference in potential energy. Now if we factor out gmm divided by r here, so we can say uh, this one is the common term. Okay, this one. And if this height h smaller is much smaller compared to the radius of the earth, or we can say h is less than r, then the potential energy will be approximately equal to mgh. So now if we have three particles having masses m1, okay, m2 and m3, what will be the potential energy? Think about it. So suppose particle first, particle second and particle third are placed in such a way, and the radius vectors between them are r12, r12, r123, okay, r123 and r13. This one is between uh, 4, we can say in between r1 and 3 r12, and in between 1 and 2 r23, and 2 and 3 in between m2 and m3. Okay, so the formula for the potential energy will be u equal to minus g is the constant, m1 into m2 divided by r12 plus g into m1 into m3 divided by r13 plus g into m2 into m3 divided by r23. Meaning that for a three particle combination, we will have three combination pairs to calculate potential energy. So this is for three particle. This is formula valid for three particles. If we have a system of n particles, in that case what will be the gravitational potential energy? So we talk about how many pairs will be formed if the number of particles is more than 3. So then these pairs will be n into n minus 1 by 2, meaning total pairs is equal to n into n minus 1 divided by 2 will be formed. Now the total potential energy of this system will be the sum of the potential energy of each pair. Okay. Now we will talk about the escape velocity. So it is somewhat evident from the name itself that this is a speed used for escaping. Okay. So what escape from what? So here the discussion is about escaping from gravitational pull of a planet. So it is the minimum velocity. Okay, listen carefully. It is the minimum velocity with which a body must be projected from the surface of the planet so that it escapes the gravitational field of a planet. We can also say that projected with escape velocity will be able to go to a point which is at infinite distance from the planet. So we can calculate the value of this speed using the conservation of energy. Okay, You know the conservation of energy? Energy neither be created nor be destroyed, only transform one form to another form. Okay, so we will apply the conservation of energy on the surface of the planet and at an infinite distance from the planet. So let's see conservation of energy. So using the conservation of energy, a value of escape velocity from the surface of a planet of mass capital M, radius capital R and acceleration due to gravity G will be V escape is equal to under root 2 into capital G into capital M divided by R. Okay, which is equal to under root 2 GR. So the escape velocity does not depend on the mass or shape or size of the body. Okay, as well as the direction of projection of the body. This is clear. So look at here in this formula. From this formula, it is clear that escape velocity. This is the formula for calculating the escape velocity. So we can say from this formula, it is clear that escape velocity does not depend on mass or shape or size of the body. Okay, because this is mass independent and this is direction independent. Okay, it depends on what? It depends on G, acceleration due to gravity, and radius. Okay, so this is the independent of mass. If we put the value, put the G, small g, and the radius of Earth in this equation given above, this equation, this value will be 11.2 kilometer per second. Okay, so this is the escape velocity, minimum velocity with which a body must be projected from the surface of the Earth so that it escapes the gravitational field of the Earth. Let's talk about satellites. Any body that revolves around the Earth or any other planets is called a satellite. These satellites can be natural or artificial. Okay, so natural means they are inherently provided by nature, like the moon, okay, for the Earth. And artificial means they are manually placed in orbit around the planet. So we know two types of satellites: artificial satellites and natural satellites. If we talk about the path of the satellites, so we can say the path of these satellites is elliptical. But sometimes to simplify calculations, we assume that the satellite's orbit is circular. So now the here we can say satellite is revolving in a such an orbit. What will be its orbital velocity? It means what? It means here a question arises, what will be its orbital velocity? So we can say the satellite's orbital velocity will be V naught equal to under root gm divided by r, which is equal to under root gr square divided by r, which is equal to under root gr square divided by r plus h. And the important point here is this: here h is the height from the surface of the Earth. If our h is very small, it means what? It means h is less than radius of the Earth. Meaning if the satellite is at a very low height, then V naught will become under root gm divided by r. In terms of acceleration due to gravity, it will become under root gr. Okay, so if we put the value of acceleration due to gravity and radius of the Earth, uh, it will be equal to V naught equal to 7.9 kilometer per second. To solve these type of questions, you need to remember the formula of orbital velocity and escape velocity. Okay, everyone. So there is a relation between escape velocity and orbital velocity, and that relationship we can say V escape is equal to root 2 into V orbital. So if you know the value of orbital velocity, okay, so just multiplied by root 2, you will be get the escape velocity. And if you know the value of escape velocity, just divide by root 2 and you will be get the orbital velocity. Okay, so this is the relationship. All right, everyone. Now we will understand the period of revolution of a satellite. It is the time taken by a satellite to complete one revolution around the earth. Meaning, we can say this is the time a satellite takes to complete one full orbit around the earth. If we push, we can also write planet right here planet because we can, when we write planet, this concept becomes more general. So this is the time any planet takes to revolve around the sun. If we consider the satellite's orbit to be circular, okay, then the formula for the period of revolution will be t equal to 2 pi r divided by v naught. Okay, meaning simply distance, this one 2 pi r and upon speed v naught. If we substitute the value of speed into this, it will be 2 pi into under root r cube divided by gm, which is equal to 2 pi into under root r cube divided by gr square. Alright, so this is the revolution period. Now, if r, small r, radial distance is approximately equal to capital R, okay, in that case, the revolution period capital T is equal to 2 pi into under root r by g, which will be approximately 84.6 minutes. Okay, everyone? Yes or no? Any doubt here? If you have any doubt, please ask. All right. Next comes our satellite's height in terms of its time period of revolution. So, at what height a satellite is placed to have a given time period? So, this comes out to be h equal to r minus capital R is equal to g into r square t square divided by 4 pi square whole power 1 by 3 minus r. Okay, so these formulas are very important. Okay, everyone. Now comes the satellite's energy. This is kinetic energy and potential energy of the satellite. So the satellite's kinetic energy will be k, which is equal to 1 by 2 m v naught square. If we substitute the value of orbital speed into this formula of the kinetic energy, it will be gm into m divided by 2r. Okay, and if we talk about the potential energy of the satellite, so it will be u equal to minus gmm divided by r. So we have a two energy, kinetic energy and potential energy. What will be the energy of the satellite, or we can say total energy of the satellites? So the total energy of the satellites is equal to sum of the kinetic energy of the satellite plus potential energy of the satellites. So the total energy of the satellites E equal to K plus U. Here K is the kinetic energy, U is the potential energy. So we know the kinetic energy G mm divided by 2R, and we also know the potential energy minus G mm divided by R. So when we substitute the value of kinetic energy and potential energy, okay, you will be get E equal to minus G mm divided by 2R. Okay, so look at here, minus g mm divided by 2r. So from this formula, here a question arises. I think this is the kinetic energy with negative sign. Yes or no? So we can say yes, you are right. G mm divided by 2r is the kinetic energy. So we can substitute the value of k, term of k. So it will be become minus k. Okay. So there is a relation between total energy and kinetic energy. So we can say total energy is equal to what? It will be minus of the kinetic energy. So directly from this relation you can see that the kinetic energy of the satellite will be equal to minus of kinetic energy. So the total energy of the satellite is equal to minus of kinetic energy. So we can say minus gmm divided by 2r. So okay everyone, or we can also write it as minus k. So note that here uh, kinetic energy has not been written as negative. So the kinetic energy is always positive, and remember this point. But if we multiply it by a minus sign, it is equal to the total energy. So from this relation we can say total energy is equal to minus of kinetic energy. Okay, kinetic energy is never be negative, it will be always positive. Okay, now we will discuss about binding energy of the satellite. This is the energy that is required to remove the satellite from its orbit and it take it to be infinity. So the binding energy formula is binding energy equal to minus E is equal to plus GMM divided by 2R. Okay. Angular momentum of a satellite. So the angular momentum of satellite will be equal to M L equal to M into V naught into R. Okay. Now we will substitute the value of V naught here. So it will be become under root M square G into M into R. Next we have the geostationary satellite. So basically a geostationary satellite is a special type of satellite, alright, whose time of revolution is 24 hours. In the same sense as that of the earth, one of its characteristic is that it appears stationary to an observer on the earth. This means that it will appear stationary when viewed from the earth's surface, because the time period of rotation uh, of the earth and the geostationary satellite is same. So it is also known as parking satellite. Okay, so all these formulas are very important for the exam. So here this is our summary. We already discussed Kepler's law of planetary motion. There is a three laws: law of orbits, law of areas, and law of periods. Then gravitational potential energy, the formula is U equal to minus gmm divided by r. Then escape velocity, the formula is V equal to under root 2 gm divided by r. And then satellites, and then orbital velocity of satellite V equal to under root gm divided by r. Then period of revolution, then height of satellite in terms of period, then energy of the satellite, then binding energy of satellite, and angular momentum of satellite, then geostationary satellite. Alright. So these are the important concepts for the exam that we already learned. Thank you for your attention. Now students, we will discuss some practice questions based on these topics. Alright. So are you ready for the practice question? Yes or no? If you're ready, so thumbs up in the chat box. Yes or no? Everyone, are you ready? Hello everyone. Now we will discuss some practice questions based on gravitations. Gravitation. All right. This is our disclaimer. So here we will discuss some practice question based on gravitation. So the first question here: a solid sphere of density rho and radius capital R. The gravitational field at a distance r from the center of the sphere when radial distance r is less than radius of the solid sphere, okay, is what? So here we need to find out the gravitational field at a distance r from the center of the sphere. Okay everyone, so the given options: option A, rho pi g r cube divided by r; option B, 4 pi g rho r square divided by 3; option C, 4 pi g rho r cube divided by 3r square; option D, 4 pi g rho r divided by 3. So which one is the correct option? You have to find out the correct one. So please try to solve this question. Here you have to find out the uh, gravitational field at a distance r. Okay, please solve. You have some time. Yeah, I expect answer from everyone. Which one is correct? Okay. So the correct answer is option D, 4 pi g rho r divided by 3. Let's see the solution. So according to question, look at here. This is a solid sphere, okay, and the density is rho, radius capital R, and we have to find out the gravitational field at a distance r from the center of the sphere. All right. So from this illustration, it is clear that small r is less than capital R. Okay. So the formula for calculating the gravitational field at a distance r is given by I equal to gm into r divided by r cube. Okay. Here small r is the radial distance and capital R is the radius of the solid sphere. Alright. So this means gravitational field inside varies linearly with the distance. So from this relation, this formula, look at here. It is clear that the gravitational field is directly proportional to R. Okay. So here if we substitute the expression for mass in terms of density and volume, the final expression will be I equal to gr divided by r cube multiply with 4 by 3 pi r cube into rho. Okay. So cancelling the common terms, r cube r cancel out, and the remaining terms is I equal to 4 pi g rho r divided by 3. Alright. So this is the correct answer. Okay everyone. Let's move to the next question. The question is a full maximum vertical distance uh, through which a full dressed astronaut can jump on the earth is 0.5 meter. Estimate the maximum vertical distance through which he can jump on the moon, which has a mean density 2/3 that of the earth and the radius of 1/4 that of the earth. Okay. So here, given that moon's density is 2/3 of the earth density and moon's radius is 1/4 of the radius, so we have the find out the maximum vertical distance the same astronaut will be able to jump on the moon. So the given options: option A 1.5 meter, option B 3 meter, option C 6 meter, and option D 7.5 meter. So which option is correct? Please try to solve everyone. Yes, Varsha, VK, Karthik, which one is correct? Which one is correct? Okay, anyone? Yes, which option? Which option is correct? Here you have to find out the maximum vertical distance. Okay, anyone? So the correct option is B. Okay, 3 meter. Good. Uh, the concept that will be used here is that initial kinetic energy is the same on both Earth and the Moon. So assuming the astronaut exerts the same force. So the formula for gravity for a planet body is given in terms of radius and mass density. Gm equal to 4 by 3 4 pi g into rp into rho p. Now we will substitute the moon's radius and density into this. Okay. So the given gravity on the moon, it will be gm equal to 4 by 3 pi into g into re divided by 4 into 2 rho e divided by 3. Okay. So gm equal to 1 by 6 into 4 by 3 uh, pi g re into rho e. So when we solving this, you will be get gm equal to 1 by 6 into ge. Okay. Here we will now use the conservation of energy to solve the question. Okay. The person will jump on the moon with the same kinetic energy with which they jumped on the earth's surface. It means the maximum height an astronaut can jump is limited by the initial kinetic energy they can uh, generate from their lag muscles, which remains the same on the earth and the moon. So this kinetic energy is converted into gravitational potential energy at the peak of the jump. So the work done in jumping on the earth and the moon will be the same. So the formula for calculating work done in jumping on the moon, WE equal to m into g into height, that is 0.5. Okay. So work done in jumping on the moon, Wm is equal to m into g. The value of g in the case of moon, it will be g by 6 into h1. Alright. So when we solving these two expressions and when we equate both We and Wm, you will we get the value of h1. So please try to solve this question. What is the value of h1? Yes. Now this is easy. Yes or no? So we have Wm equal to m into g by 6 into h1. So when we equate both We equal to Wm, so it will be m into g into 0.5 is equal to m into g by 6 into h1. So when we solving this expression, you will be get h1 equal to 0.5 into 6. Okay. So h1 will be 3.0 meter. Alright everyone, clear? Next question. A spaceship has a mass of uh, that is 1000 kilogram. It is to be launched from the earth's surface out into free space. The value of small g and radius of the earth are 10 meter per second square and 64 kilometer respectively. So the required energy for this work will be what? Okay. So here question ask about the what will be the required energy for this task. The given options: option A 6.4 into 10 raised to the 11 joule, option B 6.4 into 10 raised to the 8 joule, and option C 6.4 into 10 raised to the 9 joule, and option D 6.4 into 10 raised to the 10 joule. So tell me which option is correct. Yes, please solve this question and try to find the correct option. Everyone. Which one is the correct option? So the correct option is C, 6.4 into 10 raised to the power 10 joule. So according to question, listen carefully. The mass of a spaceship is 1000 kilogram. Okay, and it is to be launched from the Earth's surface. So suppose this is the Earth's surface and the spaceship is launched from here out into free space. Okay, and here we have to find out the required energy for this work will be what. So the given terms: acceleration, the value of acceleration due to gravity on the earth, small g equal to 10 meter per second square. Radius of the earth, 64 uh, 6400 into 10 raised to power 3 kilometer. And the formula for the gravitational potential energy at the surface of the earth is minus mgr. So we will need to provide as much energy as this potential energy on the earth's surface to send it into free space. So the energy required will be negative of this potential energy. Okay, so negative of this potential energy is minus of minus mgr. When we substitute the value of mgr, you know, the value of r, that is 64 100 into 10 raised to power 3, and value of g 10, and value of m 1000 kilogram, it means 10 raised to the power 3. Okay, now when we solving this calculation, you will be get the E required. All right, so here we have E required equal to this one. So when we solving this expression, you will be get 6.4 into 10 raised to the power 10 joule. So this will be the required energy for the given work. All right, everyone. Now let's move to the next question. If g is the acceleration due to gravity on the earth's surface, the gain in the potential energy of an object of mass small m raised from the surface of the earth to a height equal to the radius r of the earth is what? So here you have to find out the correct option. Which one is correct? Option A 2 mgr, option B 1 by 2 mgr, option C 1 by 4 mgr, and option D mgr. Okay, so which option is correct? Yes, please try to solve this question. Here you need to take the formula of gravitational potential energy to solve this question. Okay, everyone, so please solve. Which option is correct? The correct option is B, 1 by 2 mgr. Alright, let's see the solution. So the concept we will use here is this: the gravitational potential energy of any body on the earth's surface is U equal to minus gme into m divided by r. Okay, here me is the mass of the earth, small m is the mass of the body, and r is the radius of the object. Okay, so look at here in this diagram. So capital M is the mass, and there will be three cases. Okay, first when the object inside of the body in when the object at the surface, then outside, then inside. All right. So now suppose we are looking at a height h from the earth surface, then in that case the value will be, so here u of h equal to minus gm, no gm e into m divided by r plus h. Okay. Now here the condition is at a height h equal to r, it means height is equal to radius of the earth. Okay. So here in this expression r plus h, it means what, we can say r plus r, because r equal to h. Okay. So r plus r 2r, so that's why here 2r. So u of h become minus of gme into m divided by 2r. Okay. So we have the final potential energy and the initial potential energy. From here we will find their difference. So we have this expression where m is the mass of the earth and m is the mass of the body. So for the gain in the potential energy, we will subtract the potential energy at height and the potential energy at the surface, and it will be this one, delta u. Delta u is what? Is the change in potential energy. Uh, potential energy at height h, and u the potential energy at height surface, at a surface. Okay. So we know the value of potential energy at a height h. So that is minus of gm e into m divided by 2r. And we also know the potential energy at the surface of the earth. So that is minus of gm e into m divided by r. Okay. So when we subtract the potential energies, so it will be delta u equal to minus gme into m divided by 2r. Here minus minus plus, so it will be plus gme plus into m divided by r. Okay. So when we solving this expression, so we know small g equal to gme divided by r square. So we have this expression, this one. So when we solving this, you will be get gme into m divided by 2r. Here from this expression it is clear that there is a hidden formula, that is this one, gme divided by r square. Okay. So just substitute the value of small g, acceleration due to gravity. So delta u becomes g into r square into m divided by 2r. Okay. So this is the change in or we can say gain in potential energy. So from this formula it is when we solving and cancel out the common terms, so r cancel out, so remaining term is 1 by 2 mgr. Okay. So the gain in potential energy will be 1 by 2 mgr. Alright everyone. Next question. Two bodies of masses m and 4m are placed at a certain distance r. The gravitational potential at a point on the line joining them where the gravitational field is 0 is what? So here in this question there are two bodies. One has mass small m and other has mass 4m. Both are placed at a distance r. Now we need to find the gravitational potential at a surface put at the point on the line joining them. Okay. So the given options where the gravitational potential is 0. Alright. So the given options, option A minus 4 gm divided by r, option B minus 6 gm divided by r, and option C minus 9 gm divided by r, and option D 0. So which option is correct? A, B, C, D. Please try to solve this question. Okay. Please solve. Which one is correct? Anyone? Yes, Varsha, VK, Karthik. All right. So the correct option is option C, minus 9 gm divided by r. Let's see the solution. So look at here, this figure. So according to question, let's assume that P, this one, P is a point between two masses M and 4M. Okay, M and 4M. And where the P is the point where the gravitational field is 0. Alright. So let's assume that uh, this point is at a distance x from point A. Okay. And the remaining distance will be r minus x. Why? Because the overall distance is from A to B is r. So A to P x and the remaining one P to B is r minus x. So by using the formula for potential gravitational field here, we will get the expressions, and that expression will be gm divided by x square equal to g into 4m divided by r minus x whole square. Here LHS term, the gravitational field uh, at point P from for this mass m and for this mass r minus for this mass 4 g into 4m divided by r minus x whole square. So when we solving this expression, you will be get g cancel out, cancel out, the remaining terms, therefore 4x square is equal to r minus x whole square. So it will be what? It will be 2x equal to uh, 2x equal to r minus x. Okay. So x will be r by 3. Now we will calculate the gravitational potential at this location. So the formula for the gravitational potential is minus gm by radial distance r. So we will so the potential at point P will be Vp equal to minus gm divided by x minus g into 4m divided by r minus x. Alright. So the formula for the gravitational potential is minus gm divided by x minus g into 4m divided by r minus x. So when we solving this expression by putting x equal to r by 3, so it will be uh, minus 3 gm divided by r minus 3 gm into 4m divided by 2r. Okay. So Vp is equal to minus 9 gm divided by r. So this is the correct option. So we can say C option is correct. Alright everyone. Next question. A planet in a distant solar system is 10 times more massive than the Earth and its radius is 10 times smaller. Given that the escape velocity from the Earth is 11 km per second, the escape velocity from the surface of the planet would be what? So here in this question, uh, question is that in a distant solar system there is a planet which is 10 times more massive than Earth and its radius is 10 times smaller than Earth's radius. Okay. So the given that the escape velocity from the Earth is 11 km per second, then what will be the escape velocity from the surface of this planet? So question directly ask about the escape velocity, okay, from the surface of the planet. Alright, I think question is clear. The given options, option A 1.1 km per second, option B 11 km per second, option C 110 km per second, and option D 0.11 km per second. So which option is correct? You have to find out the escape velocity from the surface of this planet. So please solve this question and tell me which option is correct. You have some time. Which option is correct? So let's solve this. So correct option is C, 110 kilometer per second. Okay, let's see the solution. So according to question, mass of the planet is equal to 10 into ME. It means 10 times of mass of the earth, where M is the mass of the earth. Okay, and radius of the planet RP equal to RE divided by 10, where R is the radius of the earth. So the formula for the escape velocity for the earth is VE equal to under root 2G into ME divided by RE. So for planet, VP equal to under root 2G into MP divided by RP. Okay. So here for to getting this expression, we should here we will put the value of RE and ME. Okay. So we know the given terms MP equal to 10 times of ME and RP equal to RE divided by 10. So just put the values. You will be get 2G into MP divided by RP. Okay. So the expression becomes VP equal to under root 100 into 2GM E divided by RE. Now we know the value of G, we know the value of ME, and we know the value of RE. So let's substitute the given data. So we will get VP equal to 10 into VE. From this expression, it is clear that VP is 10 times of VE. So we know 11 kilometer per second, that is given in this question. So when we solving this expression, you will be get 110 kilometer per second. So C option will be correct. Okay, everyone. Next question. A projectile is fired vertically upwards from the surface of the earth with a velocity kve, where ve is the escape velocity and k is less than 1. If r is the radius of the earth, the maximum height to which it will rise measured from the center of the earth will be what? Okay, so we need to find out how high this projectile can go from the center of the earth. The given options: option A 1 minus k square divided by r, option B r divided by 1 minus k square, option C r into 1 minus k square, and option D r divided by 1 plus k square. So you have to find out the correct one. Please try to solve this question, everyone. Okay, let's see question again. A projectile is fired, okay, fired vertically upwards from the earth's surface with velocity kve, where v is the escape velocity and k is less than 1, meaning it is launched with a velocity less than the escape velocity. Now if r is the radius of the earth, then what will be the maximum height this projectile can reach, which will be measured from the center of the earth. Okay, so we need to find out how high this projectile can go from the center of the earth. Please solve this question and tell me. Yes, Varsha, VK, Karthik. Which one is correct? Anyone? Okay. The correct option will be option B. R divided by 1 minus k square. So, according to question, uh, a projectile is fired vertically upwards. Look at here, this like this. Okay, from the surface of the earth. So, this one is the surface of the earth. Uh, the projectile is launched with less than the escape speed, meaning it will reach the highest point, and this is the highest point. So, at the highest point, the velocity will be 0. Okay, and the distance from the surface of the uh, surface of the earth to the highest point is small r. Okay, to solve this question, we will apply the conservation of energy at the surface and at the topmost point where the particle stops as shown in this figure. Okay, so particle stops here and launched from here. So at these 2 points we will apply the conservation of energy. Okay, so because of the force is under the gravitational force, or we know gravitational force is a conservative force. So firstly we will discuss the energy at the surface of the earth. So at the surface of the earth, uh, this one, the kinetic energy is 1 by 2 mv square plus potential energy, that is minus gmm divided by r. Okay, and at the highest point, this is at the highest point, the energy will be 0 plus minus gmm divided by r. Okay, so LHS total energy, RHS total energy. Okay, so when we equate these two energies, 1 by 2 mv square plus minus gmm divided by r equal to 0 plus minus gmm divided by h, and rearranging the terms, then you will be get the correct answer. Okay, and this is the law of conservation of energy, where the energy at this one is the energy at the surface and the energy at the topmost point. All right, everyone. So when we solving this expression, you will be get 1 by 2 v square equal to g into capital M into 1 by r minus 1 by h. So 1 by 2 v square equal to g m divided by r, 1 minus r divided by h. This is just mathematical calculations. So when uh, we performing the calculations, you will be get 1 by 2 v square is equal to g m divided by r, 1 minus r by h. Here the important point is this, the value of v which is kve, and the escape velocity is under root 2 gm divided by re. So we will substitute this data into the given equation, and then our calculation become 1 by 2 k square 2 into g into m divided by r. Okay, which is equal to gm divided by r, 1 minus r by h. All right. So arrange, we will cancel the common factors gmm. Okay, so the remaining terms, or we can say the equation will become k square equal to 1 minus r by h. So r by h is equal to 1 minus k square. Okay, so or we can write r by
1 minus k square equal to h. Okay, so we can say h equal to r divided by 1 minus k square will be correct. So this is the correct option. All right, everyone. Any doubt? If you have any doubt, please ask. Yes or no? VK Versa, Karthik. Okay. Any doubt? All right. So that's all for the today. Thank you for your attention. In next lecture, we will learn about mechanical properties of matter. All right. Thank you for your attention. Thank you.